Chapter 1. Before the Building Wakes. It is 3:30 in the morning, and the city has settled into its deepest stillness. Streetlights glow steadily over empty intersections, their light falling on pavement that will not feel a footstep for hours. Somewhere in the distance, a single car moves through a green light meant for no one. Above the rooftops, the sky holds that particular shade of dark blue that exists only in the hours before dawn, when night has fully arrived and morning has not yet begun to think about arriving. The office building sits at the edge of this quiet, its glass face reflecting the orange wash of the streetlights below. From the outside, it looks completely asleep. The parking lot beneath it is nearly empty, a scattering of vehicles belonging to people who will not be seen again until sunrise. Inside, the lobby is dark except for the soft glow of emergency lighting, small fixtures set into the ceiling that never fully switch off, casting a dim and steady light across the marble floor. The elevators wait in their shafts, doors closed, cars resting patiently at whichever floor they were last called to. There is no one to summon them. The conference rooms on the upper floors sit in darkness, their long tables and empty chairs arranged exactly as they were left the evening before, waiting for a meeting that is still many hours away. The hallways are silent in that particular way that only large buildings can be silent, a stillness that seems to have weight to it, as though the space itself is holding its breath. Security cameras mounted in the corners of the lobby sweep slowly across the same empty scene they have watched for hours, recording nothing more eventful than the faint shifting of shadows as the streetlights outside flicker in their steady rhythm. A single monitor at the darkened security desk glows faintly, cycling through camera feeds that show identical stillness on every floor. Somewhere on an upper level, a lone cleaning cart sits parked beside a bank of elevators, abandoned for the night, its supplies neatly stacked and waiting for tomorrow's shift. Outside, the wind moves gently across the building's exterior, brushing against window ledges and settling into the recessed corners of the architecture. A distant siren rises and fades somewhere across the city, the only sound to briefly interrupt the layered hush of early morning. The building itself gives no outward sign of activity. Its windows remain dark, its entrances remain locked. To anyone driving past at this hour, it would appear to be nothing more than a quiet, motionless shape against the sky. And yet, high above those quiet hallways, in places most people will never think to look, something is very much awake. Above the drop ceilings of the upper floors, hidden behind acoustic tile that no one glances up at twice, wide steel ducts run in long straight lines, carrying air that no one can see moving. On the roof, inside a low, unremarkable enclosure that most passers-by would mistake for nothing more than a mechanical shed, enormous machines continue their quiet work. Down in the depths of the building, in a mechanical room most tenants will never once enter, motors turn steadily, pumps circulate warm and cool water through miles of pipe, and soft indicator lights blink patiently on control panels that no human eye is currently watching. The building, it turns out, is not truly asleep at all. It is simply resting in the way that living things rest, with its outward activity paused while its essential functions continue quietly beneath the surface. There is a way of thinking about large buildings that most people never consider, and it begins with a simple idea. Buildings breathe. Not in the way a person breathes, with lungs expanding and contracting, but in a slower, steadier, mechanical way that unfolds continuously, day and night, regardless of whether anyone is present to notice it. A modern commercial building inhales outside air, gently conditions it, and distributes it through its interior spaces, all so that the people who will eventually occupy those spaces can breathe air that is clean, properly tempered, and free of the buildup that would otherwise accumulate in any sealed environment. This process never fully stops. Even now, in the deep hours of early morning with no one inside the building at all, this quiet breathing continues, maintained not out of necessity for any occupant, but as part of a steady rhythm that the building systems are built to sustain. At the center of this breathing process sits a machine that almost no one ever sees. It is called an air handling unit, and buildings simply refer to it, when they refer to it at all, as an AHU. It is worth pausing on the strangeness of this. A person might spend an entire career working inside an office tower, might spend decades commuting to a hospital, a university, an airport terminal, or a shopping center, might walk the same hallways 5 days a week for the whole of their working life, and never once lay eyes on the machine responsible for the very air they breathe while they are there. The air handling unit exists entirely outside the world of everyday experience, tucked away in places built specifically to be forgotten. These machines are most often found in the parts of a building that exist purely for infrastructure. Some sit inside enclosures on the rooftop, exposed to the sky but shielded from casual view by simple screening walls that keep the equipment out of sight from the street below. From above, on a satellite image, a large commercial rooftop often reveals a whole cluster of these enclosures, arranged in rows across the flat surface, each one connected to the floors beneath by ducts that vanish down through the roof deck. Others occupy dedicated penthouses, small rooftop structures that from the street look almost like an additional floor, but which contain no offices at all, only ductwork, piping, and the great steel bodies of the machines themselves, lit at night by a single security light glowing over a locked access door. Still others are placed deep within the building, in large mechanical rooms tucked between occupied floors, spaces with their own separate doors and their own separate hum, entirely distinct from the offices or hospital wings just beyond the wall. A visitor walking the hallway outside such a room would notice nothing more than a plain, unmarked door, perhaps with a small sign reading "mechanical," giving no hint of the scale of machinery running quietly on the other side. In some buildings, an entire floor is set aside purely for mechanical equipment, a level with no windows and no desks, existing only to house the machinery that keeps every other floor comfortable, a floor that tenants ride past in the elevator without the button for it ever appearing on the panel. Hospitals rely on them heavily, often with multiple units serving different wings, so that if one requires maintenance, patient care is never interrupted, and so that operating rooms and recovery wards can each be held to their own precise standards of air quality. Data centers depend on them just as deeply, though there the goal shifts slightly, less about human comfort and more about keeping delicate electronic equipment within a narrow and unforgiving temperature range. The servers themselves generating a steady, significant heat load that must be carried away around the clock without exception. Universities, with their sprawling campuses of lecture halls and laboratories, often maintain dozens of these units scattered across a single grounds, each one quietly serving its own building, its own quiet rhythm unnoticed by the students walking to early classes above. The scale of these machines tends to surprise people the first time they encounter one in person. This is not the small metal box mounted outside a residential home, the kind of unit most people picture when they hear the word air conditioning. An air handling unit serving a large commercial building can be genuinely enormous, in some cases larger than a delivery truck, stretching the length of a small room and rising well above head height. The largest units, the kind found in major hospitals or large office towers, can move tens of thousands of cubic feet of air every single minute, a volume of moving air that is difficult to picture until you are standing beside the machine that produces it. Walk slowly around one of these units, and a particular kind of architecture begins to reveal itself. The exterior is built from heavy sheet metal panels, painted a flat and utilitarian color, the kind of finish that exists purely for function rather than appearance. Along the length of the casing, rows of access doors interrupt the smooth surface, each one fitted with sturdy latches designed to hold the panel tightly shut against the pressure of the air moving inside. Some of these doors include small viewing windows, thick panes of reinforced glass set into the metal, allowing a technician to glance inside without opening the panel at all, checking on a filter or a fan simply by peering through the glass with a flashlight. Along the top and sides, the casing is lined with thick insulation sandwiched between layers of metal, dampening both the temperature of the air inside and the sound of the machinery at work. And there is sound, though it is subtle. Pressed close to the casing, a faint vibration can be felt through the metal, the gentle hum of fans and motors working steadily somewhere within. From a short distance away, this settles into little more than a soft, continuous whisper of moving air, almost entirely masked by the ambient noise of a mechanical room. Small service lights are mounted near the access panels, some triggered automatically when a door is opened, casting a brief wash of illumination across the internal components before fading again once the door swings shut. Stenciled labels appear here and there across the casing, small painted letters marking sections with names like mixing box, filter bank, and fan section, a quiet vocabulary understood only by the technicians who service the equipment. A data plate is riveted near one of the access doors, listing the manufacturer, the model number, and a set of specifications in small print, a modest plaque easily overlooked, yet containing everything an engineer would need to know about this particular machine's capacity and design. Along the base of the unit, the casing rests atop a low steel frame, raised slightly off the concrete floor, allowing space underneath for the condensate lines that will later carry away the moisture the unit collects from the air passing through it. The room that houses a unit like this has its own particular character. The floor beneath is bare concrete, sealed and slightly dusty, built to bear enormous weight without complaint. Steel support beams rise overhead, painted the same utilitarian gray as the casing of the machines themselves, forming the structural skeleton that holds the floors above in place. Large pipes run along the walls and across the ceiling, insulated in white or silver jacketing, carrying chilled water in one set of lines and hot water in another, the two temperatures kept carefully separate as they travel toward the coils inside the AHU. Valves interrupt these pipes at regular intervals, some manual, some automated, each one capable of adjusting the flow of water with a quiet, mechanical precision. Nearby, a control panel stands mounted to the wall, its face covered in small labeled switches and a softly glowing display, monitoring conditions that no person in the room is currently watching, because no person needs to be. Cable trays run overhead in neat parallel lines, carrying the wiring that connects sensors, actuators, and controllers scattered throughout the building. And above it all, the ductwork begins, wide rectangular channels of insulated sheet metal disappearing upward into the ceiling, beginning journeys that will carry conditioned air far beyond this single room, into hallways and offices the ductwork itself will never be seen from. Scattered across the panels and equipment throughout the room, small LED indicator lights glow steadily in the dim space, some green, some amber, each one signaling that a particular piece of equipment is operating normally, has failed, or is currently in some intermediate state that a technician would recognize at a glance. In the deep quiet of 3:30 in the morning, these small lights are often the only visible sign that anything in the room is functioning at all. The air inside the mechanical room carries its own particular quality, faintly warm near the piping, faintly cool near the ductwork, touched with the mild mineral scent of water moving through metal and the barely there smell of clean machine oil. A single fluorescent fixture overhead, left on for safety, casts a flat white light across the concrete floor, throwing long shadows from the pipe supports and the edges of the equipment. There are no windows here. There is no reason for windows. The room exists entirely for the machines, and the machines take no notice of daylight or darkness, running the same steady course regardless of the hour. Somewhere along the far wall, a logbook rests on a small metal shelf beside the control panel, its pages filled with the neat handwriting of technicians who visited during the day, noting readings, adjustments, and the occasional quiet observation about a valve that might need attention next week. For now, the logbook sits closed, untouched, waiting for the next visit sometime after sunrise. It is worth pausing here to consider why any of this exists in the first place. Why a building would need to move such enormous volumes of air simply to remain livable. Human bodies, it turns out, are constantly producing three things that a sealed room cannot simply absorb indefinitely: heat, moisture, and carbon dioxide. Even at rest, a person radiates a steady amount of warmth generated by the ordinary metabolic processes of being alive. That same body releases moisture continuously, both through the skin and through breathing, adding humidity to the surrounding air with every passing minute. And with every exhale, a small amount of carbon dioxide enters the room, invisible and odorless, but steadily accumulating if the air around it is never replaced. In a small space with a single occupant, this accumulation happens slowly enough to go unnoticed. But gather several hundred people into a single office floor, or several thousand into a hospital or a university building, and the effect compounds quickly. Without some mechanism to remove this heat, moisture, and carbon dioxide, and to replace it with fresh outdoor air, an occupied space would grow steadily warmer, steadily more humid, and steadily more stale as the hours passed. This is the quiet, unglamorous problem that ventilation exists to solve, and it is the problem that the air handling unit, along with the vast network of ductwork connected to it, is built specifically to address. Beyond the people themselves, a large building generates its own quiet accumulation of heat from other sources as well. Computers left running through the night, refrigeration equipment in a break room, the steady operation of lighting and electrical systems throughout the structure, all of it adds a small, continuous warmth to the interior air, even in the complete absence of any occupant. Left unaddressed, this accumulated warmth would slowly raise the temperature of a sealed building over the course of days, regardless of the outdoor climate. The ventilation system, in this sense, is not simply reacting to people. It is maintaining a kind of quiet equilibrium, a steady balance between the heat generated inside and the fresh tempered air brought in to offset it. There is also the matter of air quality in a broader sense, beyond simple carbon dioxide. Furnishings, carpeting, paint, and office equipment all release faint traces of compounds into the surrounding air over time, substances with long technical names that, in any meaningful concentration, are simply unpleasant or unhealthy to breathe. A steady supply of fresh outdoor air, continuously replacing the air already inside, keeps these compounds diluted to levels far below anything a person would notice, let alone anything that could cause harm. This, too, happens invisibly, hour after hour, without any of it ever announcing itself to the people walking the halls above. There is something worth sitting with in this idea, something easy to overlook in the business of an ordinary day. Every single breath taken inside a large building, every quiet inhale during a meeting, every exhale while sitting at a desk connects that person to an enormous hidden mechanical process working steadily somewhere out of sight. The comfort of a well-conditioned room, so easy to take for granted, depends entirely on machinery that almost no one in that room has ever seen, running continuously day and night, long before anyone arrives and long after everyone has gone home. Follow for a moment one small parcel of air. It exists right now outside the building, part of the vast and undifferentiated night air drifting slowly across the empty parking lot. It carries with it the faint coolness of early morning, the kind of temperature that settles in just before the sky begins to lighten. It is unremarkable in every way, indistinguishable from the billions of other small parcels of air surrounding the building at this hour. And yet this particular parcel happens to be drifting toward the exterior wall, toward a section of the building unlike the smooth glass and stone that makes up most of its surface. Here, near ground level or sometimes higher up along the building's side, a wide grille of angled aluminum blades interrupts the wall, arranged in rows, each blade tilted downward at a careful angle. These are louvers, and their design serves a very particular purpose. The angle of each blade allows air to pass through freely while preventing rain from following the same path, the water instead striking the metal and running harmlessly down and away rather than penetrating into the building's mechanical systems. Behind the louvers, a fine mesh screen stretches across the opening, fitted specifically to keep birds, leaves, and larger debris from entering the ductwork beyond, while still allowing air to pass through its small, evenly spaced openings. Outside, the night remains quiet. A faint breeze moves across the parking lot, stirring nothing in particular. Somewhere further off, a distant sound carries briefly on the air, the low hum of a highway a mile or two away, and then fades again into the general stillness of early morning. Somewhere closer, a sprinkler system clicks on briefly along a landscaped border, hissing softly over the grass before shutting off again a few minutes later, the only sign of any system, anywhere, actively responding to the hour. Above the louvered opening, a small weatherproof light fixture casts a faint circle of illumination down across the aluminum blades, more for the benefit of a technician arriving during daylight hours than for any purpose at night. The metal of the louvers holds a faint chill, having spent the whole night exposed to the cooling outdoor air, and a few small beads of condensation cling to the underside of each blade, gathered quietly from the humidity drifting past. Nothing about the opening suggests urgency or effort. It simply waits, as it has waited through every night before this one, ready to admit whatever air happens to drift close enough. The small parcel of air continues its slow drift, carried more by the pull of the building's own systems than by anything happening in the atmosphere around it, easing steadily closer to the louvered opening in the wall. Behind that opening, unseen from the parking lot, a fan somewhere deeper in the ductwork turns at a slow and steady speed, its gentle draw reaching outward through the louvers and the mesh screen, patiently gathering the surrounding air and drawing it, particle by particle, toward the opening. It has no way of knowing what lies beyond that opening. It does not know about the mixing chambers, the filters, the coils, or the great fans waiting somewhere deeper inside the building, all of it built specifically to receive parcels of air exactly like this one and prepare them for the long journey through the ductwork above. For now, it simply drifts, gentle and unhurried, drawing nearer to the aluminum blades and the fine mesh screen behind them, nearer to the quiet edge of the machine that has been waiting patiently through the entire stillness of the night. The building continues its slow, steady breathing. Somewhere above, a fan turns gently within its casing. Somewhere below, water moves quietly through insulated pipe. And here, at the outer wall, the night air gathers itself at the threshold of the intake, ready in time to begin. Chapter 2. The building takes a breath. The parcel of air reaches the louvers. Up close, the aluminum blades reveal themselves in full, a long row of angled fins stretching across the width of the opening, each one tilted downward at roughly the same careful pitch as the one beside it. The metal has a dull, brushed finish, worn slightly by years of weather, though never rusted, protected by a coating designed specifically to withstand rain, sun, and the slow abrasion of wind-carried dust. The angle of each blade is not arbitrary. It has been chosen so that air can pass easily between the fins, while any raindrops carried along with it strike the underside of the blade above, gather into small beads, and run harmlessly downward, dripping quietly off the lower edge and falling away outside the building entirely. In this way, the louver performs two roles at once, welcoming the air that the building needs while turning away the moisture that it does not. Behind the louvers, set back just slightly from the outer face, a fine mesh screen stretches taut across the full opening. Its purpose is simpler than the louvers above it, but no less important. Birds, drawn to the shelter of a warm opening in a cold wall, might otherwise find their way into the ductwork beyond, along with leaves lifted by autumn wind and the countless small pieces of debris that drift across any open landscape over the course of a season. The screen catches all of it, its openings small enough to stop a sparrow or a maple leaf, yet wide enough to let the passage of air continue almost entirely unimpeded. Somewhere on the building's maintenance schedule, this screen will eventually be inspected and cleared, a task performed so quietly and so rarely that most people who work inside the building will live their entire tenure there without ever knowing the screen exists at all. For a moment, right at this threshold, the air seems to pause between two worlds. Outside, the night carries its own particular texture of sound. A breeze moves gently through nearby trees, briefly lifting their leaves into a soft rustle before settling again. Somewhere far off, a dog barks once and falls silent. The occasional car passes on a distant road, its engine rising and fading within the span of a few seconds. These are open sounds, unconfined, traveling freely across long distances the way sound only can outdoors, arriving and departing without any wall to stop them. Beyond the louvers, inside the mechanical room, the character of sound changes entirely. Here, everything is close and contained. The soft mechanical hum of fans and motors fills the space evenly, a continuous, low frequency that never rises or falls, more felt in the chest than heard by the ear. There is a faint metallic resonance to it, the sound of moving air inside sheet metal ductwork, muffled by insulation and thickened by distance from its source. No single sound stands out from another. Everything blends into one steady presence, patient and unchanging, utterly unlike the scattered, unpredictable sounds of the outdoors. It is the sound of a system built to run the same way at 3 in the morning as it does at 3 in the afternoon, indifferent to the hour, indifferent to who might or might not be listening. The parcel of air passes through the screen, through the angled blades, and crosses fully into the building's mechanical world. There is no dramatic marker of this crossing, no visible line where outside ends and inside begins. The transition happens the way most transitions happen inside a building like this, gradually and without ceremony, a slow easing from one condition into another. Behind the louvers, the duct briefly widens into a shallow plenum, a quiet holding space no larger than a small closet, where the incoming air gathers for a moment before continuing onward. The metal walls of this small chamber are lined with the same thick insulation found throughout the system, both to steady the temperature of the air and to dampen whatever faint sound might otherwise carry back out through the louvers toward the parking lot below. Just beyond the louvers, the path narrows into a short section of ductwork, and here the first true decision-making component of the journey waits quietly in the dark. This is the outside air damper, a bank of wide metal blades mounted on a shared axle, stretching the full width of the duct. At this hour, the blades sit at a modest angle, neither fully open nor fully closed, allowing a measured trickle of outdoor air to pass through, while the building maintains only the minimum ventilation it requires during these unoccupied hours. The blades themselves are unremarkable to look at, flat panels of galvanized steel, painted a plain gray, hinged along one edge so that each can rotate independently within its frame, though in practice they are all linked together, moving in perfect unison. What makes them worth pausing on is not their appearance, but the quiet precision of their movement. Mounted to one end of the shared axle sits a small electric actuator, a compact motor housed in a gray plastic casing, connected to the building's control wiring. At intervals throughout the night, this actuator turns, just slightly, adjusting the angle of every blade at once by a few degrees in either direction. The motion is slow enough that it could easily be missed entirely, a smooth, unhurried rotation that takes several seconds to complete, followed by long stretches of stillness before the next small adjustment occurs. Somewhere else in the building, inside a server rack or a dedicated control room, the building automation system is quietly making the calculations that drive these small movements. It does this constantly, without pause, drawing on a steady stream of information gathered from sensors scattered throughout the structure. It considers how many people are expected to occupy the building in the hours ahead, drawing on schedules programmed months in advance. It considers the temperature and humidity of the outside air at this exact moment, comparing it against conditions inside. It weighs the cost of conditioning that outdoor air against the benefit of bringing in a larger volume of it, seeking always to strike a balance between comfort, air quality, and the efficient use of energy. None of this calculation announces itself. There is no sound, no visible sign beyond the occasional slow rotation of the damper blades, and yet an enormous quantity of quiet reasoning stands behind that simple, patient motion. An entire logic system devoted to something as understated as deciding, moment to moment, how far to open a set of metal blades. The building's reasoning extends further than the damper alone. Elsewhere, similar small adjustments are unfolding in parallel, each one shaped by the same underlying logic. A pump somewhere below eases its speed very slightly. A valve rotates by a fraction of a degree. None of these changes exist in isolation. Each is part of a much larger, continuously updating picture that the building automation system maintains of the entire structure, a kind of quiet awareness spread across hundreds of sensors and dozens of pieces of equipment, all of it working toward the same modest goal of keeping the building comfortable and efficient without ever asking anyone to think about it. On a night as still as this one, with no occupants to serve and no immediate demand to meet, the system settles into its most conservative rhythm, making only the smallest adjustments necessary to hold conditions steady until the pace of the day eventually returns. Past the damper, the duct opens into a much larger space, tall enough in places to stand inside, wide enough that the sound of the mechanical room seems to soften and spread out, filling the whole volume evenly rather than pressing in from any one direction. This is the mixing section, and here, for the first time, our small parcel of outside air is no longer alone. Arriving from another direction entirely through a separate duct connected to the return air system, warmer air drifts steadily into the same chamber. This return air carries with it the residue of the building's interior, faint traces of it gathered from wherever it has been. Some of it has traveled down from an upper office floor, carrying the mild warmth of computer equipment left running overnight and the faint scent of carpet and drywall. In buildings of a different kind, this same return path might carry air gathered from hotel corridors, still faintly carrying the last traces of the evening's activity, or from hospital hallways, kept within careful limits before ever reaching this chamber, or from classrooms sitting empty until morning, or from the wide, echoing terminals of an airport, where the air has spent the day mingling among thousands of travelers before finally finding its way back here into this quiet chamber to begin the cycle again. Much of this returning air has already been conditioned once, either warmed or cooled by the very system it is now returning to, carrying with it a portion of the energy already spent to bring it to a comfortable temperature. The meeting of outdoor air and return air inside the mixing box is a quiet, almost gentle event. There is no dramatic collision, no visible turbulence, only a slow and steady blending as the two streams converge within the shared space of the chamber. The outdoor air, cool and slightly damp with the last traces of night, drifts in from one side. The return air, warmer and carrying the faint residue of the building's occupied hours, drifts in from the other. Between them, in the open volume of the mixing box, invisible currents curl gently against one another, swirling in slow, unhurried patterns before settling into a single, blended stream. No two parcels of air mix in quite the same pattern twice, the currents shaped by the smallest variations in temperature, pressure, and the exact position of the dampers at that particular moment. And yet the result, moment after moment, remains steady and consistent, an even tempered blend flowing onward toward the next stage of the journey. There is something almost meditative in the movement of this chamber, if such movement could be watched at all. No single current travels in a straight line for long. Each is nudged gently by its neighbors, deflected softly by the walls of the space, drawn briefly one way by a slightly warmer thread of air before settling again into the slower, steadier drift of the whole. Over the span of only a few seconds, the sharp distinction between outdoor air and return air dissolves entirely, replaced by a single uniform body of air, evenly tempered, carrying forward the combined character of both sources without any trace of where either one began. This blending serves a purpose that runs deeper than simple convenience. By combining a portion of already conditioned return air with fresh outdoor air, the system spares itself the far greater cost of conditioning the entire volume of air from outdoor conditions alone. Bringing in 100% outdoor air, particularly on a very cold or very hot night, would demand an enormous amount of additional heating or cooling capacity, consuming far more energy than the building actually requires to remain comfortable and properly ventilated. By blending instead, the system provides enough fresh air to maintain healthy indoor air quality, while relying on the return air to carry forward a meaningful share of the conditioning already achieved. It is, in its own quiet way, an act of conservation built directly into the architecture of the machine. The mixing dampers, similar in construction to the outside air damper encountered a few moments earlier, sit at the entrance to this chamber, one bank controlling the flow of return air, another controlling the continued flow of outdoor air. Like their counterpart, these dampers shift position slowly and deliberately throughout the night, guided by the same quiet calculations happening elsewhere in the building. As outdoor temperatures drift lower in these final hours before dawn, the dampers may ease very slightly further closed on the outdoor air side, favoring a marginally larger share of return air to conserve warmth. As the building begins to sense the earliest signs of an approaching morning, drawing on schedules and forecasts alike, they may begin, almost imperceptibly, to shift the other way, preparing the ventilation system for the fresh air demands of an occupied day still hours away. All of this occurs in increments too small to notice in any single moment, the sum of many gentle adjustments spread across the length of the night. Our parcel of air, having entered as a distinct and separate thing, is now no longer quite so easy to trace. It has folded into the larger current, indistinguishable from the return air surrounding it, part of a single blended stream drifting steadily onward through the chamber. And yet, in the way that a single drop remains part of a river even after it can no longer be singled out, it continues its journey, carried forward now as part of something larger than itself. The mixed stream moves onward, drawn by the same gentle draft that has guided it since the outdoor louvers, passing beneath a wide steel frame that marks the beginning of the filtration section. Here, the character of the space changes once again. Where the mixing box was open and cavernous, this next section narrows into a series of parallel tracks, each one holding a large, rectangular filter arranged side by side across the full width of the duct like the pages of an enormous book standing on end. The frames holding these filters are simple galvanized steel slotted into place along guide rails, sealed at the edges with thin strips of gasket material to prevent air from slipping around the filter rather than through it. The first filters the air encounters are known as pre-filters, and their purpose is deliberately modest. Built from a coarser material, sometimes a simple pleated fabric, sometimes a looser mesh, pre-filters exist to catch the largest and most obvious particles before they can travel any further into the system. Lint dust clumps, the occasional stray leaf fragment that slipped past the outdoor screen, insect fragments and other coarse debris are pulled from the passing air here, trapped gently among the fibers of the pre-filter media. Because these filters handle the bulk of the coarser material, they also tend to fill and require replacement more frequently than what lies beyond them, a small, unglamorous task performed periodically by a technician who will spend only a few quiet minutes here before moving on to the next stop on a much longer round sheet. The pre-filters wear their work openly, darkening gradually over the weeks between replacements, a faint gray shadow spreading slowly across the pale fabric until, one day, a fresh white filter takes its place, and the cycle begins again. Beyond the pre-filters, air passes into a second bank, this one built to a noticeably higher standard. These final filters are deeper and more tightly pleated, folded again and again into a dense accordion shape that dramatically increases the surface area of fiber the air must pass through, all while fitting into a housing not much larger than the pre-filter before it. It is this density of fiber and the fineness of the material itself that determines just how small a particle the filter is capable of capturing. Engineers describe this capability using a rating system known as MERV, though the letters themselves matter far less than what they represent. In the simplest terms, a MERV rating is a way of describing how finely a filter can sieve the air passing through it, a single number that quietly summarizes an enormous amount of engineering and testing behind the material itself. A lower-rated filter might catch only the coarser particles, much like the pre-filter encountered a moment ago. A higher-rated filter reaches much further, capable of capturing particles so small that dozens of them could rest side by side across the width of a single human hair, particles like fine dust, pollen grains, and many of the microscopic fragments that drift invisibly through ordinary air without ever being noticed. Hospitals and laboratories often call for the highest ratings available, filtering their air to a standard far beyond what an office building would typically require, while a school or an office tower might settle comfortably on a more moderate rating, one that balances air quality against the energy cost of pushing air through an increasingly fine barrier. It is, in the end, a quiet trade-off, weighed once by the engineers who designed the system and then left to operate on its own, night after night, without further debate. Deep within the fibers of these final filters, the real work of filtration happens on a scale far too small to see. Each fiber, magnified many times over, resembles something closer to a tangled forest than a smooth surface, an intricate lattice of overlapping strands creating countless narrow passages for air to wind through. As particles are carried along within the airflow, they collide gently with these fibers, some caught outright by the sheer narrowness of the gap, others drawn in by the faintest electrostatic pull between particle and fiber, invisible forces working quietly at a scale far below anything the eye could ever observe. Bit by bit, particle by particle, the filter grows very slightly more efficient as it accumulates this fine layer of captured material, even as it very slowly begins to restrict the flow of air passing through. The building notices this slow accumulation long before any person would think to check. Mounted just before and just after the filter bank, two small pressure sensors continuously measure the air on either side, watching for the subtle difference that develops as a filter gathers more and more trapped material. In a clean filter, air passes through with relatively little resistance, and the difference between the pressure on either side remains small. As dust and debris accumulate within the fibers, that difference grows, slowly and steadily, an invisible signal building over days and weeks, even as the filter itself continues to look, from the outside, exactly as it did the day it was installed. The building automation system watches this reading constantly, comparing it against a threshold set long ago by the engineers who designed the system, quietly noting the slow drift without any urgency, simply recording, comparing, and waiting. When the difference eventually crosses that threshold, a small notification will appear on a screen somewhere, a simple, unremarkable message informing a technician that it is, at last, time to replace this particular filter. For now, on this particular night, the reading remains comfortably within range, and the filters continue their quiet work undisturbed. Our parcel of air, still folded seamlessly into the larger blended stream, drifts into the dense pleats of the final filter bank. It winds through the tangled fibers, brushing past countless strands too small to see, some tiny fragment of dust or pollen that had been traveling alongside it since somewhere out in the night, finally catching against a fiber and coming to rest there, left behind as the rest of the stream continues onward. What emerges on the far side of the filter bank is, in some small but genuine way, cleaner than what entered it. The invisible clutter of the outdoor night and the building's own interior, gently strained away, fiber by fiber, in complete silence. For a brief moment, the air moves through an open stretch of duct beyond the filter bank, a short, unremarkable passage with nothing in it but steady, quiet flow. The mechanical room hums on around it, indifferent and constant, the same low frequency that has accompanied every step of the journey so far. Somewhere overhead, a single indicator light on the filter monitoring panel blinks its slow, steady green, confirming, without any need for a human eye to see it, that all remains well. Ahead, in the dim, steady hum of the mechanical room, the coils wait. Rows of narrow copper tubing, wrapped in fine aluminum fins, sit motionless in the path of the airflow, filled with water carried in from somewhere else in the building, water that has its own long and quiet story still to tell. The parcel of air, newly filtered, drifts steadily onward, carried by the same slow current that has guided it since the outdoor louvers, moving now toward that next quiet threshold, close enough to feel the faint change in the air just before it, but not yet close enough to cross it. Chapter 3. Becoming Comfortable. The air emerges from the filter bank and drifts into open space once more, the tight, dense pleats of fabric giving way to a wider section of duct, quieter now in its own particular way, as though the air itself has settled after the fine sifting it has just passed through. Ahead, the character of the mechanical room shifts again. Where the filtration section felt narrow and orderly, lined with rows of identical frames, the space beyond opens into something taller, cooler, and more deliberate in its arrangement. This is the heating and cooling section, and it is here, more than almost anywhere else inside the air handler, that the true purpose of the entire machine becomes visible. Rows of copper tubing rise from floor to ceiling, arranged in tight, even ranks, each tube no thicker than a finger, bent in long, gentle curves that carry it back and forth across the width of the duct many times over before it finally exits through a heavy steel frame at either side. Threaded onto this copper, thousands upon thousands of thin aluminum fins stand in perfect parallel formation, spaced only a fraction of an inch apart, catching the dim light of the mechanical room and scattering it into a soft, silvery shimmer along the length of the coil. Seen up close, the effect is almost architectural, a dense, orderly lattice built entirely from repetition, thousands of nearly identical surfaces standing shoulder to shoulder, all serving the same quiet purpose. Beneath this array, a shallow steel pan stretches the full width of the unit, sloped gently toward one corner, its surface catching whatever moisture might eventually gather above it and guiding it patiently toward a drain fitting. Nearby, mounted along the outer frame, small brass valves interrupt the piping at intervals, their handles turned to specific positions and left untouched for months at a time, adjusted only when a technician has good reason to do so. A slim metal probe extends into the duct just past the coil, connected by thin wire to a sensor somewhere on the control panel, quietly reporting the temperature of the air the moment it leaves the coil's surface. Beyond the frame, the piping continues, disappearing into the wall of the mechanical room, following its own separate path toward the boilers and chillers waiting elsewhere in the building. Machines with their own long story, one this particular chapter will not follow all the way to its source. The atmosphere here carries its own quiet coolness, a faint chill in the air near the cooling coil, a subtle warmth lingering near the heating coil just beside it, the two temperatures coexisting only a few feet apart, separated by nothing more than open space and the steady flow of air moving steadily past both. The light in this part of the mechanical room falls differently than it did among the filters. A single caged fixture overhead throws its glow directly down across the coils, catching the polished edges of the aluminum fins and scattering into countless small points of reflection, an effect not unlike moonlight caught on the surface of rippling water. Look closely enough, and a faint sheen of condensation can sometimes be seen clinging to the lower half of the cooling coil even now. Tiny beads gathering slowly along the underside of the fins, catching the light in brief, scattered glints before eventually falling away. The heating coil beside it shows no such sheen, its surface dry and faintly warm to the touch, radiating the mildest suggestion of heat outward into the surrounding air, noticeable only to a hand held close enough to feel it. It is worth pausing here before the air continues its journey to consider something easy to overlook. The coils themselves create nothing. They generate no heat, produce no cold, manufacture nothing at all in the way a furnace or a refrigerator compressor might. Their role is simpler and, in its own way, more elegant. A coil exists only to exchange energy, to allow warmth to move quietly from wherever it happens to be more abundant toward wherever it happens to be less abundant, following a principle so fundamental that it operates constantly, everywhere, whether inside a building or out beneath the open night sky. Thermal energy, at its heart, always drifts from warmer objects toward cooler ones, gently and without exception. The same way water always settles toward the lowest available point. A cup of coffee left on a counter slowly cools, its warmth easing outward into the surrounding air until both settle at the same temperature. A cold glass of water left in a warm room slowly loses its chill, absorbing warmth from the air around it until the difference disappears. This same quiet exchange, magnified many times over and carefully controlled, is exactly what happens as air passes across the surface of a coil deep inside the air handling unit. No mysterious process invents new heat or erases old heat. Warmth simply moves, following its own patient, invisible logic, always from warmer to cooler, until some kind of balance is reached. There is a certain comfort in recognizing how ordinary this principle truly is, how the very same quiet exchange happening deep inside this mechanical room also happens constantly, everywhere, in the smallest and least remarkable corners of daily life. It happens in the fogging of a bathroom mirror after a hot shower, in the slow cooling of a meal left too long on a table, in the gentle warming of a cold hand held for a moment inside another. Nothing about the physics changes as it scales upward into a machine the size of a delivery truck. The building has simply arranged with great care and precision for this same simple tendency of warmth to move from one place to another to happen exactly where and when it is needed. The heating coil, encountered first along this stretch of the journey, carries hot water somewhere within its tangle of copper tubing, water that arrived here after being warmed elsewhere in the building, most often inside a boiler housed in its own separate mechanical space. That boiler, working quietly through the night much like everything else in this story, heats water to a carefully maintained temperature and sends it circulating outward through a network of insulated piping, arriving eventually here, inside this particular coil, ready to give up a portion of its warmth to the air passing by. In some buildings, particularly older ones or those built around a central steam plant, this same role is filled instead by steam rather than hot water, the vapor condensing quietly within the coil and releasing its stored heat in the process, though the underlying principle remains the same regardless of which medium carries the warmth. As air drifts across the heating coil, It does not experience any sudden burst of warmth, no dramatic wave of heat rolling through the duct. Instead, the warming happens gradually, almost imperceptibly, as countless small parcels of air brush past the heated surface of each fin and each length of tubing, absorbing a small measure of warmth with each passing moment. By the time the air reaches the far side of the coil, it carries with it a noticeably higher temperature than it held only a few feet earlier, though the transition itself unfolded so smoothly that no single instant could be pointed to as the moment the change occurred. There is something quietly peaceful in picturing the water itself, unseen inside its copper tubing, circulating endlessly through the building in a slow, continuous loop. It leaves the boiler warm, travels through walls and ceilings and mechanical rooms, arrives here to share a portion of its heat, and then continues onward, cooler now, back toward the boiler to be warmed once again, over and over, hour after hour, an endless, patient circulation that never truly stops, even in the stillness of 3 a.m. On this particular night, with the outdoor air still carrying its early morning chill, our parcel of air passes beneath the reach of the heating coil only briefly, the dampers upstream having called for only the smallest touch of warmth to offset the cooler air blended in from outside. The coil obliges quietly, without hesitation, offering exactly the measured degree of warmth the system has determined is needed, no more and no less. A short distance beyond, the cooling coil waits, similar in construction but entirely different in what it carries. Here, rather than hot water from a boiler, chilled water arrives instead, sent from the chiller plant elsewhere in the building, water cooled through its own separate, elaborate process, arriving at the coil already carrying a temperature far below that of the air about to pass across it. In other buildings, rather than chilled water, the coolant coil might instead hold refrigerant directly, a system engineers refer to as a direct expansion coil, in which the refrigerant itself expands and cools within the copper tubing, absorbing heat directly from the passing air without any water serving as an intermediary. Both approaches accomplish the same essential task, differing mainly in the equipment required to prepare the fluid that ultimately does the cooling. As air drifts into contact with the cooling coil, the same principle of heat transfer plays out once again, only now the direction has reversed. Rather than the coil warming the air itself gives up its heat, surrendering warmth to the far colder surface of the coil and its fins. Follow the parcel closely here, gliding between one narrow gap after another among the dense ranks of aluminum, each fin only a breath away from the next, the air weaving a long, unhurried path through thousands of these tiny corridors before finally emerging on the far side. With every passing fin, a small measure of warmth transfers away, the air growing incrementally cooler with each step of its passage, until by the time it clears the final row, it carries a noticeably lower temperature than it held only moments before. Something else begins to happen here as well. Something visible in a way that heat transfer alone rarely is. As warm, humid air meets the cold surface of the coil, it can no longer hold on to all of the moisture it was carrying. Warmer air, it turns out, is capable of holding far more water vapor suspended invisibly within it than cooler air can manage, a simple physical reality that governs everything from the fog that gathers on a cold window to the dew that settles across a lawn at dawn. as the air's temperature drops sharply upon contact with the coil. That invisible moisture has nowhere left to remain suspended, and so it condenses, gathering instead as liquid water directly onto the cold metal surface in front of it. At first, this appears only as the faintest film across the aluminum fins, barely visible even up close. Slowly, moment by moment, that film gathers into small individual droplets, each one clinging to the underside of a fin, growing steadily larger as more moisture condenses around it. Eventually, gravity overtakes whatever surface tension had been holding a droplet in place, and it releases, falling the short distance down through the coil and landing with a soft, almost inaudible sound in the shallow steel pan waiting below. This happens continuously, unevenly and quietly, hundreds of droplets forming and falling across the surface of the coil at any given moment, an unhurried, steady rhythm of gathering and releasing that continues for as long as air keeps moving across the cold metal. The drain pan beneath the coil exists entirely for this purpose, its gentle slope guiding every collected droplet steadily toward a single corner where a length of piping waits to carry the water away. This condensate line runs quietly out of the mechanical room, following its own modest path through walls and ceilings, eventually delivering its collected water into the building's ordinary drainage system, joining the same infrastructure that carries away water from sinks and floor drains throughout the structure. It is a small, unglamorous conclusion to a process that begins with something as vast and invisible as humidity drifting through the night air outside. Yet it plays a quietly essential role, preventing water from ever accumulating where it should not, keeping the coil section dry and orderly, even as it continuously produces the very water it must then carry away. There is a kind of patience built into this whole arrangement, one easy to miss amid the steady hum of everything else happening around it. The drain pan does not rush the water along, nor does it need to. It simply waits, sloped and steady, receiving whatever falls and guiding it onward at whatever pace the coil happens to produce it, sometimes a slow trickle on a mild night, sometimes a steadier, more constant flow when the outdoor air arrives especially humid. The piping beyond makes no distinction between the two, carrying either pace onward with the same unhurried indifference. Comfort inside a building, it turns out, depends on more than temperature alone. A room held at a perfectly pleasant temperature can still feel unmistakably wrong if the air within it carries too much moisture or too little. Overly humid air tends to feel heavy and close, clinging faintly to the skin, making even a mild temperature feel warmer than it truly is. Overly dry air brings its own quiet discomfort, a faint tightness in the throat, a static charge that gathers unexpectedly on doorknobs and countertops, materials throughout the space slowly shrinking and cracking in ways barely noticeable from one day to the next. Somewhere between these two extremes lies a narrow, comfortable range, one that building engineers work carefully to maintain, adjusting for it just as deliberately as they adjust for temperature itself. In certain buildings, maintaining this balance calls for equipment beyond the cooling coil alone. Hospitals often require carefully humidified air to protect sensitive patients and equipment from the discomfort and static risk of overly dry conditions, particularly during the colder months when outdoor air itself carries very little moisture to begin with. Museums and archives, tasked with preserving fragile documents, paintings and artifacts across centuries depend on precise humidity control to prevent the slow, irreversible damage that either overly dry or overly damp conditions can cause to delicate materials. Laboratories, too, often maintain their own strict humidity requirements, dictated less by comfort and more by the particular sensitivity of the instruments and processes housed within. In buildings across the coldest climates, where outdoor winter air arrives almost entirely devoid of moisture, dedicated humidifiers quietly add a controlled mist of fine water vapor back into the airstream, restoring a measure of the humidity that heating alone would otherwise strip away entirely. Dehumidification, by contrast, happens here largely on its own, an almost incidental byproduct of the cooling process already underway. As the cooling coil draws warmth from the passing air, it draws away a portion of that air's moisture as well, the two processes occurring together, inseparably, every time air meets a sufficiently cold surface. Engineers describe the moisture content of air using a measurement called relative humidity, a simple way of expressing how much water vapor the air currently holds compared to the maximum it could possibly hold at that particular temperature. Air at a high relative humidity feels heavy and damp. Air at a very low relative humidity feels dry and thin. Somewhere in the comfortable middle, most people find the air simply feels like nothing at all, neither damp nor dry, simply present, exactly as air should feel. There is one further concern that quietly shapes the design and operation of this entire section, one that becomes especially relevant on the coldest nights of the year. Coils, for all their steady and reliable operation, share a particular vulnerability. Should the water inside them ever drop low enough in temperature to freeze, the resulting ice would expand within the copper tubing with tremendous force, more than enough to rupture the tubing itself, causing damage that could take a coil out of service for days or longer, an outcome the building's engineers have taken great care to prevent from ever occurring. To guard against this, a series of quiet safeguards stand watch throughout the coil section, ready to act long before any actual danger could develop. Low-temperature sensors, sometimes called freeze stats, stretch across the width of the duct just downstream of the coil, a long, thin sensing element capable of detecting even a single small pocket of dangerously cold air anywhere along its length. This design matters more than it might first appear, since cold air does not always distribute evenly across the width of a large duct. A single narrow streak of frigid outdoor air, perhaps drawn in greater proportion through one corner of the mixing dampers than another, could otherwise slip past unnoticed by a sensor placed in only one location. The freeze stat's winding serpentine length exists specifically to prevent that kind of narrow, hidden risk from ever going undetected. Should that sensor ever detect a temperature approaching the freezing point, it triggers an immediate automatic response. The outside air damper, so carefully modulated only a short while earlier in the journey, would swing rapidly closed, shutting off the flow of cold, outdoor air entirely. The supply fan, waiting just ahead, would shut down at once, halting airflow altogether. Heating valves would open fully, flooding the coil with the warmest water available in an effort to drive away any risk of freezing. All of this would happen within moments, a swift, decisive sequence of actions carried out entirely without human involvement. The building recognizing danger and responding to it long before anyone arrived to notice a problem at all. Somewhere on a screen inside a control room, an alert would appear, calmly logged and time-stamped, a quiet record of a crisis that never truly had the chance to become one. On this night, none of these safeguards have any reason to act. The mixed air arriving at the coil section remains comfortably above any temperature that would concern the freeze sensors, and the whole system continues its steady, unremarkable operation, the quiet, protective logic standing by unused, the way a fire extinguisher hangs unnoticed on a wall for years without ever needing to be lifted from its bracket. It is easy to forget, walking past such things in daylight, that their entire purpose is to remain forgotten, to simply be ready indefinitely for a moment that may never come. It is worth remembering, if only for a moment, just how many people this small, quiet exchange ultimately serves. Somewhere above this mechanical room, in offices and hallways that stand empty right now, hundreds of people will arrive in only a few hours, each one about to step into air that has already been prepared for them long before their alarm clocks ever sound. None of them will think about the coils, the condensate, or the careful balance of humidity maintained on their behalf. They will simply notice, without noticing, that the air feels right, comfortable in a way too subtle to name, and they will go about their day never once wondering what made it so. Our parcel of air, having passed fully through this section, now carries a different character than it held only minutes ago. It arrived already cleaner, sifted gently through layers of filtration. Now it has changed once more, its temperature adjusted, its moisture drawn down to a more comfortable level, prepared in every measurable way for the space it will eventually reach. It is no longer the same restless night air that once drifted idly across an empty parking lot. It has become something quieter, steadier, and more deliberate, shaped entirely by machinery it will never see and never need to understand. Ahead, a low, steady sound begins to grow very slightly louder, a deep, rhythmic presence rising gradually out of the general hum of the mechanical room. Somewhere just beyond the coils, in a section of the unit not yet visited, the large supply fan continues its endless, patient turning, waiting quietly to draw this newly conditioned air onward, out of the coil section and into the long, dark passage of ductwork that will eventually carry it far beyond this room entirely. The parcel of air drifts steadily toward that sound, carried forward as it has been carried through every stage of the journey so far, unhurried, weightless, and entirely at ease within the quiet machinery of the sleeping building. Chapter 4. The Giant Fan. The air clears the last row of the cooling coil and drifts into open space once more, carrying with it the faint, settled coolness of everything it has just passed through. Ahead, the low hum that has followed this journey since the very first louver begins almost imperceptibly to change. It does not grow louder so much as it grows nearer, the same steady frequency that once seemed to fill the whole mechanical room evenly, now beginning to gather itself into a single direction, a single source, waiting somewhere just beyond the next section of casing. A faint vibration passes through the sheet metal panels lining the duct, subtle enough that a hand resting against the wall might mistake it for nothing more than the ordinary tremor of a large building settling into its own weight, though anyone who has stood in this room before would recognize it immediately for what it is. The casing itself widens here, the tight rectangular geometry of the coil section giving way to something broader and more substantial, Heavy steel framing rises along the perimeter, thicker than anything encountered earlier in the unit, bolted together with a solidity that speaks to the forces contained within. Large access doors interrupt the casing at intervals, each one considerably heavier than the panels near the filters, fitted with reinforced hinges and multiple latches, built to remain firmly sealed against the pressure generated just behind them. Small inspection windows are set into several of these doors, thick reinforced glass offering a narrow private glimpse into the chamber beyond without ever requiring the door itself to be opened. Around the edges of the section, protective guards made of expanded steel mesh cover any point where a hand might otherwise stray too close to moving machinery, a quiet, unremarkable safeguard, easy to overlook and essential all the same. Thick electrical conduit runs along the outer wall, disappearing into a junction box before continuing onward, carrying the wiring that will soon deliver power to whatever waits just ahead. Overhead, a single service light glows steadily, casting its pale illumination across the heavy steel doors, waiting patiently for the technician who will eventually open them. A small placard is mounted near the largest of the doors, its lettering worn but legible, warning in the plain, unembellished language of industrial signage that the equipment beyond should never be serviced while in operation, a caution so ordinary it barely registers, yet standing as a quiet reminder of just how much force waits patiently behind this particular wall of steel. The floor here carries a faint tackiness underfoot, the residue of years of careful lubrication applied to nearby bearings, wiped away as thoroughly as any technician could manage, but never entirely erased. Nothing about the space rushes toward its reveal. The documentary camera, if there were one, would move slowly here, lingering on the heavy latches, the reinforced hinges, the small brass plate identifying the manufacturer, allowing the anticipation to build not through any dramatic device but simply through the unhurried pace of genuine attention. The narration lingers here, in this brief threshold before the reveal, the same way a documentary camera might pause just outside a doorway before finally stepping through. Beyond the final access door, in the wide, tall chamber it protects, the fan wheel turns. It is, without question, one of the largest single components inside the entire air handling unit. A great cylindrical or curved structure built from riveted sheet steel, easily large enough that a person could stand upright inside its open center were it not, at this very moment, spinning steadily on its axis. Dozens of curved blades extend outward from its core, each one shaped with the same careful precision as an aircraft propeller, angled just so to catch the surrounding air and drive it purposefully forward with every rotation. Painted a plain industrial gray, faintly scuffed in places from years of steady use, the wheel carries no ornamentation of any kind, its entire design given over completely to function. A faint band of polished metal traces the outer edge of each blade, worn smooth by decades of moving air brushing endlessly across the same narrow surface, the only visible mark of just how many millions of rotations this particular wheel has already completed since the day it was first installed. Different air handling units favor different arrangements of this wheel, and the choice reflects the particular demands of the building it serves. Some machines rely on a single large centrifugal fan, a design in which air is drawn in along the fan's axis and thrown outward in a wide curving path before being redirected forward into the ductwork, the same basic principle found in machines many times smaller, simply scaled up to a size capable of moving an entire building's worth of air. Others, particularly larger installations, favor what engineers call a plenum fan, a design without the surrounding housing found on a centrifugal fan, instead spinning openly within the larger cabinet of the unit itself, drawing air in from all directions before releasing it forward. Still others abandon the idea of a single large fan altogether, relying instead on a fan array, a cluster of several smaller fan wheels mounted side by side, working together in unison to accomplish what a single large fan would otherwise do alone. This approach offers its own quiet advantage, since if one fan within the array ever required service, the others could continue running, allowing the building to maintain at least a portion of its airflow rather than losing ventilation entirely. The choice between these designs depends on the size of the building, the volume of air required, the physical space available for the mechanical room, and the particular priorities of the engineers who designed the system many years before this quiet night ever arrived. A hospital, for instance, might favor the redundancy of a fan array, unwilling to risk even a temporary loss of ventilation to a critical wing. A modest office tower with simpler needs and a tighter mechanical budget might find a single well-sized centrifugal fan more than sufficient for everything it will ever be asked to do. Whichever design a given building has chosen, the wheel itself rotates now with a steady, unhurried patience, completing each revolution in barely more than a fraction of a second, and yet appearing from a short distance away, almost calm in its motion, the blur of its blades settling into something that looks less like violent effort and more like a slow, continuous breath. It is easy to underestimate, standing here in the quiet of the mechanical room, just how much air this calm, steady motion is actually capable of moving. A fan of this size, turning at a modest and unremarkable speed, can easily draw tens of thousands of cubic feet of air through the unit every single minute, enough to fill a modest house with fresh air several times over in the time it takes to read a single sentence describing it. And yet none of this scale announces itself through drama. There is no roar, no shudder, no sense of strain in the wheel's steady rotation. It simply turns the way it has turned every night for years, the way it will continue turning long after this particular parcel of air has completed its journey and been replaced, invisibly, by countless others following the same quiet path behind it. Our parcel of air, still carrying the newly adjusted temperature and moisture it gained only a few moments earlier, drifts steadily nearer to this great turning wheel. There is no sudden pull, no dramatic rush of acceleration. Instead, the air simply gathers speed gradually, the way a slow current gathers speed as a riverbed narrows, drawn forward by the quiet, steady draft the fan maintains at all times. The fan does not violently seize the air and hurl it forward. Its role is subtler than that, and in its own way more impressive. Rather than forcing each individual parcel of air through the ductwork by brute effort, the fan works instead by steadily building pressure, creating a gentle but persistent difference between the air just behind it and the air waiting somewhere far ahead, a difference the surrounding air naturally moves to equalize, flowing onward simply because it is easier in this moment to flow than to remain still. Driving this great wheel, mounted just behind it or, in some configurations, connected through a system of belts, sits the motor responsible for all of this quiet effort. It is a heavy, unremarkable cylinder of steel, considerably larger than the motor found in almost any household appliance. Its outer casing ribbed with a series of cooling fins running along its length, allowing the surrounding air to draw away the mild heat generated as it works. A junction box on its side houses the electrical connections feeding into it, thick insulated cable disappearing into the casing through a sealed fitting. There is nothing dramatic in its appearance, no bright colors, no unnecessary detail, only the quiet, confident solidity of a machine built to run continuously for years at a stretch without complaint. Motors of this kind rarely draw attention to themselves, and that, in a sense, is precisely the point of their design. A well-engineered motor does not announce its presence through noise or heat or visible effort. It simply performs the same task over and over at the same steady output for years on end, its reliability measured not in any single dramatic moment, but in the sheer, uninterrupted accumulation of ordinary ones. Somewhere on its casing, a small metal tag lists its specifications in worn, faded print, horsepower, and voltage, and a manufacturing date now many years in the past, the only visible record of a machine that has otherwise given no outward sign of its age. Inside that casing, the motor performs its own quiet transformation, converting the electrical energy delivered to it into steady mechanical rotation, the same fundamental principle found in motors of every size, from the smallest kitchen appliance to the largest industrial equipment scaled here to a size capable of driving a wheel many times the motor's own size. In some units, this motor connects directly to the fan wheel through a single shared shaft, an arrangement engineers call direct drive, the motor and fan spinning always at precisely the same speed, coupled together with a rigid, unwavering precision. In other units, particularly older designs or those requiring a wider range of possible speeds, the motor instead drives the fan through a system of belts stretched taut between two pulleys, the motor spinning at its own steady pace while the belts translate that motion to the fan wheel at a different, carefully chosen speed. Bearings support the rotating shaft at key points along its length, precisely machined and quietly lubricated, allowing an enormous heavy wheel to spin for years with only the faintest whisper of friction. Vibration isolation, in the form of thick rubber pads or coiled steel springs, sits beneath the entire fan and motor assembly, absorbing what little imbalance remains in the rotation before it can travel outward into the surrounding structure, keeping the great turning wheel from ever announcing itself too loudly to the building around it. Smooth rotation, above nearly everything else, is what this careful assembly of bearings, shafts, and isolation exists to protect, since even the smallest imbalance in a wheel this size and speed, left unaddressed, could in time shake itself loose from the very foundations meant to hold it steady. Nearby, mounted to the wall in its own dedicated steel enclosure, a smaller cabinet hums quietly with an entirely different character of sound, a faint, high electronic tone rather than the deep mechanical presence of the fan itself. This is the variable frequency drive, often shortened simply to VFD. And though it lacks any of the visible scale of the fan or its motor, its role in this section is every bit as important. Behind its closed steel door, banks of electronic components regulate the precise character of the electricity delivered to the motor. and on its face a small display glows softly, cycling through a quiet sequence of numbers, a percentage here, a frequency there, numbers that mean little to anyone but the technician who occasionally checks them. A handful of small indicator lights blink beside the display, steady and unhurried, confirming without any need for further explanation that everything within the cabinet continues to operate exactly as intended. There is something quietly reassuring in the presence of this small cabinet, standing apart from the far larger equipment surrounding it, doing its own modest work without ever needing to raise its voice. Where the fan and its motor represent raw physical capability, the drive represents something closer to judgment, the quiet intelligence that decides, moment to moment, exactly how much of that capability the building actually needs to call upon. The principle behind this quiet cabinet is simpler than its name might suggest. Ordinary electricity arrives at a fixed, unchanging frequency, and a motor left to run directly on that unmodified power would have little choice but to spin at a single, constant speed, running full tilt whether the building needs a great rush of air or only the faintest trickle. The variable frequency drive changes this entirely, taking in that fixed electrical supply and reshaping it, adjusting the frequency of the power delivered to the motor in small, precise increments, and in doing so, adjusting the very speed at which the motor and the great fan wheel connected to it chooses to turn. A slightly higher frequency coaxes the fan to spin a little faster. A slightly lower frequency allows it to ease back, turning more slowly, moving less air, drawing less power in the process. It is, in effect, a kind of quiet negotiation carried out continuously between the building's actual needs and the fan's willingness to work only as hard as those needs require. Because of this, the fan rarely holds exactly the same speed for very long. Across the length of any given night, and far more dramatically across the length of any given day, the VFD makes countless small adjustments, easing the fan's speed up or down by the smallest of margins as conditions shift throughout the building. At this hour, in the depths of early morning with the structure almost entirely unoccupied, the fan turns at a modest conservative pace, moving only as much air as the building's minimal overnight ventilation truly requires. In a few hours, as the first arrivals begin filling the parking lot and stepping through the front doors, the VFD will begin coaxing the fan gradually faster, matching its effort to the rising demand with the same quiet precision it demonstrates now. Never overreacting, never falling behind, simply tracking the building's actual needs as closely as the electronics allow. Underlying all of this lies a concept engineers refer to as static pressure, a term that sounds more complicated than the idea itself truly is. Rather than imagining the fan as something that reaches out and physically shoves each parcel of air down the length of every duct in the building, it helps instead to picture it as something quietly pressurizing an enormous invisible river of air that already fills the entire ductwork system from end to end. The fan does not chase down individual parcels of air and push them toward their destination one at a time. It simply raises the pressure of the air immediately around it, and that pressure spreads outward through the connected ductwork the way pressure spreads through any connected system of pipes, gently nudging the entire river forward, all at once from the coil section all the way out to the farthest diffuser in the farthest room of the building. Picture for a moment a long garden hose lying coiled and full of water. Squeeze one end shut, and pressure builds instantly throughout the entire length of the hose, felt everywhere along it in the same instant, not just at the point where the squeeze occurred. The ductwork behaves in much the same way, an enormous branching hose filled from end to end with air rather than water, its pressure rising and falling as one connected whole every time the fan adjusts its effort, even in branches of the ductwork lying far beyond where the fan itself is turning. Small pressure sensors, easy to overlook amid the larger equipment surrounding them, are mounted at intervals throughout the duct system, tucked quietly into the sheet metal at points chosen carefully by the engineers who designed the system. Each one continuously reports back to the building automation system, describing, in a steady stream of numbers, exactly how much pressure currently exists at that particular point in the network. Drawing on these readings, the system continuously fine-tunes the fan's speed through the VFD, seeking always to maintain just enough pressure to deliver comfortable, adequate airflow to every space the ductwork serves, without maintaining even the smallest amount more than necessary. Too little pressure, and rooms at the far end of the ductwork might receive less air than they need. Too much, and the fan spends needless energy pressurizing a river of air larger than the building actually requires. Between these two outcomes lies a narrow, ever-shifting target, one the system pursues continuously, adjusting the fan's speed in small increments dozens of times throughout the course of a single hour, a quiet, patient rhythm of correction that never fully settles and never needs to. It is a form of restraint as much as it is a form of control, the building asking of its fan only exactly what is needed and no more, hour after hour, without ever being asked to do so. The parcel of air, having gathered its gentle speed in the approach, now passes fully into the reach of the great spinning wheel, swept briefly among its curved blades before being released, with the rest of the current surrounding it, into the open chamber just beyond. There is no violence in this passage, no sudden turbulence, only the steady, purposeful acceleration that has been building since the moment the fan first came into view. What emerges on the far side carries with it a new sense of direction, a current no longer simply drifting but now moving with clear and deliberate intent, propelled forward by the quiet pressure the fan has spent this entire moment building around it. Ahead, the character of the space changes entirely. Where the fan section felt wide and open, filled with the presence of turning machinery, the passage beyond narrows into something long, straight, and comparatively featureless, a corridor of smooth, galvanized sheet metal stretching forward until it disappears into darkness. This is the main supply duct, the beginning of a journey that will eventually carry this current of air far beyond the mechanical room entirely, out past the walls that have contained every part of the story so far. Its interior walls are cool and faintly reflective, catching what little light reaches this far and scattering it thinly along the duct's length. Here and there, gentle curved veins are fixed at the corners where the ductwork must bend, angled surfaces designed to guide the moving air smoothly around each turn, without allowing it to tumble or lose its steady, purposeful pace. There is a quiet efficiency to this stretch of the journey. None of the intricate detail found among the coils or the filters, only a long, undecorated passage built for one purpose alone, and beyond the reach of the mechanical room's light, the duct continues onward, rising gradually upward, vanishing into the darkness of the ceiling above, carrying our parcel of air forward into the unseen structure of the sleeping building. Behind it, the mechanical room continues exactly as it has all night, the fan turning steadily, the motor humming beneath it, the VFD quietly counting its small patient adjustments. None of it pauses to notice the parcel of air's departure. There is always more air arriving behind it, drawn endlessly in through the same louvers, filtered through the same fibers, tempered by the same coils, gathered by the same turning wheel, an unbroken procession stretching back through the entire length of the night and forward into whatever remains of it, each parcel following the last along the same quiet, well-worn path, disappearing now into the long, dark corridor of steel that will carry it at last toward the rooms where someone in only a few hours will finally breathe it in. Chapter 5. The Journey Through the Building. Beyond the fan, the duct opens into something vast, a long rectangular channel of galvanized steel, rising higher overhead than a person could reach and stretching wide enough that several people could walk it side by side, though no one ever will. This is the main supply duct, the trunk from which every other pathway in the building's invisible circulatory system will eventually branch, and for now it runs in a single, unbroken line, disappearing into the darkness beyond the reach of the mechanical room's dim lighting. Its walls carry a quiet, functional beauty of their own, smooth panels of sheet metal joined at regular intervals by reinforced seams, each one folded and fastened with the same careful precision as the panels before it, running in a long, continuous ribbon toward wherever the ceiling above happens to lead. Occasionally, where the duct must bend to follow the shape of the building rather than the shape a straight line would prefer, curved turning vanes appear within the corner of the turn, thin metal blades set at careful angles, guiding the moving air smoothly around each corner without allowing it to tumble or separate from the walls the way an unguided current might. Every so often, a short section of flexible material interrupts the rigid metal, a soft accordion-like fabric connector allowing for the smallest amount of give between one section of ductwork and the next, absorbing the gentle vibration of the fan before it can travel too far down the line. Overhead, at regular intervals, thin steel hangers descend from the structure above, threaded rods anchored into the concrete deck, cradling the duct's considerable weight and holding it steady exactly where the original drawings, drafted years earlier, once specified it should sit. A faint layer of dust has settled along the very top of the duct over the years, invisible from below, undisturbed by anything but the occasional technician crawling past on an inspection walk. A small, harmless testament to just how rarely this particular corridor of the building receives any human visitor at all. Where sunlight might eventually filter faintly through a distant roof access hatch during the day, none reaches here now. The entire corridor lit only by the faint glow of a maintenance worker's flashlight on the rare occasion one passes through, and otherwise left in a darkness as complete and undisturbed as anywhere else in the sleeping building. Inside, the air moves with a calm, unhurried presence. No rushing wind, no audible turbulence. Only the faintest whisper of movement carried along smooth metal walls. a sound so gentle it would be easy to mistake for silence entirely if a person happened to stand quietly beneath it in the dark. This is the beginning of an invisible transportation network, one that reaches eventually into nearly every occupied corner of the building above, though no single person walking those halls would ever guess at its presence from below, since above their heads lies only an ordinary ceiling, tile after tile of the same unremarkable material, giving no hint of the great steel corridor running quietly just beyond it. Our parcel of air travels the length of this trunk duct only briefly before the pathway begins, gradually and deliberately, to divide. At a wide junction marked by another gentle turning vein, a portion of the moving air peels away into a smaller branch, the duct itself narrowing noticeably at this point, tapering down from its original generous dimensions into something more modest. This narrowing repeats itself again and again as the ductwork continues its journey, each successive branch smaller than the one before it, following a simple logic that governs the entire network. The main trunk must carry enough air to serve dozens of rooms at once, and so it remains wide and generous throughout its length. Each branch, however, need only carry enough air for the smaller handful of rooms it alone is responsible for serving, and so it can shrink accordingly, conserving material, conserving space above the ceiling, and helping maintain the steady pressure the fan worked so carefully to establish only a short while earlier. The transitions between these different sizes are never abrupt. Sheet metal fittings, shaped like gentle tapering cones, ease the duct from one dimension into the next, avoiding any sudden constriction that might otherwise create unwanted turbulence or noise. Where a branch must turn to follow a hallway or thread between two structural beams, the bend arrives softly, curved rather than sharp wherever the available space allows, the ductwork bending politely around whatever obstacles the building's architecture happens to place in its path. Along much of this route, the ducts run parallel to bundles of electrical conduit and thick fire sprinkler piping, the whole crowded, hidden world above the ceiling sharing its narrow space in careful, coordinated arrangement, each system given just enough room to complete its own particular task without ever quite touching the one beside it. Here and there along the branch ducts, a small manual damper interrupts the smooth metal, a simple adjustable blade set into the duct at a fixed angle and locked into place with a single bolt. These are balancing dampers, and their purpose has nothing to do with the moment-to-moment adjustments made elsewhere in the system. Instead, they were set once, carefully, by a technician working through the building shortly after construction, walking from branch to branch with a measuring instrument in hand, adjusting each damper by hand until every corner of the building received its fair and proper share of the air the fan was providing. Once set, a balancing damper rarely moves again, remaining fixed in that same careful position for years. A quiet, permanent correction, ensuring that a room near the beginning of the duct run receives no more air than a room much farther along it, despite one lying so much closer to the fan than the other. There is something almost old-fashioned about this particular piece of the system. A single mechanical adjustment made once, by hand, at the very beginning of a building's life, and then trusted to hold true for decades afterward, quietly outlasting nearly every occupant who will ever work beneath it. Elsewhere along this hidden pathway, a different kind of damper waits, one built for a purpose far more serious than balance alone. At certain points, most often where ductwork must pass through a fire-rated wall or floor separating one section of the building from another. A fire damper sits quietly within the duct, its curved steel blades held open at this moment by a simple metal link, allowing air to pass through freely, exactly as it does at every ordinary hour of every ordinary day. That link, however, has been engineered with a very particular vulnerability. It is designed to melt quickly and reliably the moment the surrounding temperature rises to a level consistent with an actual fire, and the instant it does, the blades it was holding open snap shut under the force of a coiled spring, sealing the duct completely, preventing flame and smoke from following the same convenient pathway the building's own air was using only a moment before. In ordinary operation, on a night such as this one, the fire damper does nothing at all, remains entirely open, entirely unnoticed. Its presence known only to the engineers who specified it and the inspectors who periodically confirm it will still function exactly as intended. There is a particular kind of comfort in a device built this way, one whose entire value lies in doing absolutely nothing for years at a time and doing it reliably. No one walking the halls of this building will ever think to thank the fire damper for its silence, and that silence is, in fact, exactly what its designers hoped for. Closely related and often mounted in similar locations, smoke dampers serve a purpose that overlaps with the fire damper's own, though their trigger differs. Rather than waiting for heat alone, a smoke damper responds to the detection of smoke itself, closing quickly at the first sign of it in order to prevent smoke from drifting silently through the ductwork into rooms far from any actual flame. Since smoke, in most fires, poses its own serious danger long before heat ever reaches those same distant spaces. In many modern buildings, engineers combine both functions into a single device, a combination fire smoke damper capable of responding to either threat, closing at the detection of smoke or the melting of its thermal link, whichever comes first, standing guard quietly within the ductwork for the entire span of its service life, waiting for an event that, in most buildings, will hopefully never come. Our parcel of air, having passed safely through several of these quiet, watchful guardians without ever triggering so much as a flicker of response, continues onward, following its branch duct toward a small rectangular enclosure mounted just above the ceiling of the room it is about to serve. This is a variable air volume box, known throughout the industry simply as a VAV box. And though it lacks any of the visible grandeur of the fan or the coils encountered earlier in this journey, it plays a role every bit as essential to the comfort of the room just below it. Housed within a modest sheet metal casing, not much larger than a small suitcase, the VAV box contains a single adjustable damper of its own, this one connected not to a fixed bolt, but to a small electric actuator, capable of shifting the damper's position continuously throughout the day in response to instructions arriving from elsewhere in the building. A slim temperature sensor extends from the box, or sometimes from a small wall-mounted plate within the room itself, quietly reporting the current conditions back to the box's own small control circuit. Thin control wiring connects the whole assembly to the building's larger network, a modest, unremarkable bundle of cable easily mistaken, at a glance, for nothing more than ordinary electrical wiring. A faint mechanical click sometimes accompanies the actuator's movement, barely audible even in the otherwise silent space above the ceiling, the only outward evidence that the box has just made one of its countless small adjustments. Most people standing in the room below would never hear it at all, separated as they are by a layer of ceiling tile and insulation, entirely unaware that the comfort they are quietly enjoying is the product of a decision made only moments earlier, directly above their heads. The purpose of this small, quiet device is to adjust continuously and independently exactly how much conditioned air enters the particular room it serves. Where the fan and the coils work to prepare a single, shared supply of air for the entire building, no two rooms ever demand precisely the same amount of that air at precisely the same moment. A room facing the morning sun might warm more quickly than one facing away from it. A crowded conference room generates far more heat simply through the presence of so many people than the same room sitting empty. The VAV box exists to account for these countless small differences, opening its damper further when a room calls for more cooling, easing it back when conditions inside settle closer to what the room's occupants prefer. In a large building, this same small device repeats itself by the hundreds, sometimes by the thousands. One VAV box tucked above nearly every room, every open office bay, every hotel corridor segment, each one reporting continuously back to the building automation system, and each one receiving its own quiet, individual instructions in return. The system does not treat the building as a single, undivided space, but rather as an enormous collection of small particular spaces, each with its own quiet needs, each attended to separately and simultaneously, a scale of coordination almost impossible to picture directly, and yet unfolding, in practice, without any real difficulty at all. Some rooms served by this network occasionally call for something the primary supply air, cooled at the coils only a short while earlier, cannot provide on its own. A conference room sitting empty on a cold morning, or an exterior office catching the full chill of a winter wind through its windows, may need a touch of additional warmth even while the rest of the building continues receiving air already cooled to serve its busier, more heat-generating neighbors. To meet this need, many VAV boxes include a small reheat coil built directly into their casing, positioned just after the box's own damper, ready to add a final, modest measure of warmth to the air before it continues on toward the room. Some of these reheat coils rely on electric elements, simple resistance heaters warming the air directly as it passes across them, drawing power much like the smallest space heater might. Others carry hot water instead, delivered by its own thin branch of piping traveling alongside the ductwork, offering the same gentle warming through the same quiet principle of heat transfer encountered earlier in this journey, at a scale considerably smaller than the great heating coil back within the air handling unit itself. Our parcel of air passing through its own particular VAV box without the need for any reheat on this quiet, temperate morning continues onward into one final short stretch of ductwork, narrower now than any it has passed through so far, leading at last to a ceiling diffuser waiting somewhere just above the room it is about to enter. Diffusers themselves come in a variety of familiar shapes, though few people walking beneath them ever pause to consider their design. Square ceiling diffusers, perhaps the most common of all, sit flush within the grid of an ordinary drop ceiling, their surface patterned with a series of concentric blades or perforations, designed specifically to spread the incoming air outward in a gentle, even pattern rather than allowing it to fall straight down in a single noticeable column. Linear slot diffusers, often found along the perimeter of a room near windows, appear instead as long, narrow openings running the length of a ceiling or wall, delivering air in a thin, even sheet, particularly useful where a steady curtain of the conditioned air can help offset the temperature swings of a nearby window. Round diffusers, simpler still in appearance, direct air outward in a wide, even circle, often chosen for their unobtrusive profile in spaces where a more decorative ceiling pattern matters more than in an ordinary office. Whatever their particular shape, all of them share the same underlying purpose: taking a single, concentrated stream of air arriving from the narrow ductwork above and spreading it gently outward across the room below, dispersing it so thoroughly that no occupant ever feels anything so crude as a draft, only the vague, pleasant sense that the room simply feels comfortable without any clear sense of why. The engineering behind this gentle dispersal is more deliberate than it appears. A diffuser positioned carelessly or shaped without proper consideration of the airflow passing through it might instead send a narrow, noticeable jet of air directly down onto whoever happens to be sitting below. An unpleasant, distracting sensation, entirely at odds with the goal of comfort the whole system exists to achieve. The particular curve and spacing of each blade within a well-designed diffuser exists specifically to prevent this outcome, coaxing the air instead into a wide, slow-moving pattern that spreads evenly across the ceiling before gently settling downward, arriving at head height, if it arrives there at all, with barely enough remaining motion to stir a single loose paper on a desk. And so, at last, our parcel of air drifts downward through the diffuser and enters the room itself. Here, in the quiet hour before sunrise, it finds an office arranged in careful stillness, chairs pushed neatly beneath desks, computer monitors dark, a lone desk lamp left on by habit rather than necessity, casting a small pool of warm light across an otherwise shadowed room. Elsewhere in the building, the same network delivers its quiet current into a classroom, rows of empty chairs facing a whiteboard still bearing the faint ghost of yesterday's lesson, waiting now for a group of students who remain at this hour still fast asleep in their own homes across the city. In a hospital several floors below, the same invisible system reaches a quiet corridor where a night shift nurse walks slowly past closed patient doors, the air around her carrying the same careful balance of temperature and freshness found in every other space this network serves, adjusted here with even greater care given the particular needs of those resting just beyond each door. In a hotel not far away, the same principle unfolds behind a closed guest room door, air drifting quietly across a sleeping traveler who will wake in a few hours with no thought at all for the machinery that kept their room so comfortably still through the night. And in a conference room left otherwise untouched since yesterday afternoon's meeting, papers still stacked neatly at one end of the table, the same quiet current moves through, maintaining a room that no one currently occupies, simply because maintaining it costs less and disrupts less than the alternative. None of these spaces look alike. None of the people who will eventually occupy them share very much in common with one another. And yet the same fundamental journey, the same parcel of night air drawn in through a rooftop louver hours earlier, filtered, tempered, pressurized, and distributed with such extraordinary care, now quietly serves every one of them in turn, indistinguishable in the end from the countless other parcels following the very same path behind it. Consider for a moment just how many separate journeys like this one are unfolding at this very hour, not only within this single building but across every other structure sharing the same skyline, each one running its own version of the same quiet process, entirely independent of the others, entirely unaware of the others, and yet each accomplishing in its own hidden way the exact same modest goal. A hospital several blocks away conditions its own air through its own separate machinery. An airport terminal across the city moves its own vast volume through its own network of ducts. None of these systems know of the other's existence, and none of them need to. Each simply continues its own quiet work, tending to its own small portion of a much larger invisible pattern repeating itself night after night across every occupied structure in the world. This, perhaps, is the quiet truth at the center of the entire system. Comfort, for nearly everyone who experiences it, remains almost entirely invisible. A person settling into a desk chair, adjusting to the temperature of a room without a single conscious thought, has no reason to consider the fan, the coils, the dampers, or the small VAV box quietly working just above the ceiling tiles overhead. They simply expect the room to feel right, the way a person expects a light switch to summon light or a faucet to summon water, without ever pausing to trace the hidden path either convenience actually travels to reach them. But even this careful, quiet delivery is not the end of the parcel's journey. Somewhere along the far wall of the office it now occupies, a simple rectangular grill sits mounted near the ceiling, its slats angled gently inward, offering no obvious clue that its purpose runs in the opposite direction from the diffuser only a short distance away. This is a return grill, one of many scattered throughout the building, some set into ceilings, others mounted low along interior walls, each one connected to its own quiet duct, running back through the same hidden spaces above the ceiling tiles. Slowly, gradually, drawn now by the same gentle pressure difference that once pulled it forward through the supply system, our parcel of air begins to drift toward that grill, gathering itself alongside countless others doing exactly the same thing throughout every occupied and unoccupied space the building contains. It passes through the return grill and into the duct beyond, joining a current considerably larger than the one it left only a short while ago, merging together with air gathered from hallways, from stairwells, from the edges of the very conference room it briefly passed through. Much of this returning air, still carrying the mild imprint of the space it just came from, will eventually make its way back to the very air handling unit where this entire journey first began, ready once again to be measured, filtered, tempered, and sent back out into the building, the same quiet cycle beginning once more, exactly as it has continued, uninterrupted, through every hour of this long, still night. Chapter 6. The Invisible Conversation. Our parcel of air drifts quietly through the return grill and into the duct beyond, joining the slow-gathering current that will, in time, carry it back toward the very machine where its journey first began. But even as this familiar physical movement continues, another journey is unfolding at the very same moment, one made not of moving air but of moving information, threading invisibly through the walls and ceilings of the building in a network every bit as extensive as the ductwork itself, though far less visible to anyone who might think to look for it. Every modern commercial building, in its own quiet way, constantly measures itself. This happens continuously, without pause, in every corner of the structure at once. A temperature reading is taken in an office on the 14th floor. A pressure reading is taken deep within a duct above a hallway. A small sensor near a rooftop unit notes the current humidity of the outdoor air. Another, tucked inside a conference room, quietly tracks the slow rise and fall of carbon dioxide as the room fills and empties throughout the day. Elsewhere, a fan reports its current speed. A valve reports the exact position of its stem. A damper reports how far open or closed its blades currently sit. None of these individual observations amounts to very much on its own. A single number here, a single reading there, and yet gathered together continuously across every corner of the building, they form something remarkably close to a form of awareness, a building quietly conscious, in its own limited mechanical way, of its own condition at every passing moment. It is worth pausing to consider the sheer scale of this quiet self-observation. A single mid-sized office tower might easily contain several thousand individual points of measurement, each one reporting its own small piece of information many times every minute, day and night, without ever pausing, without ever growing tired, without ever once needing a moment's rest. Across the span of a single day, this amounts to millions of individual readings, an almost unimaginable quantity of quiet, unremarkable data, each piece so small and so unremarkable on its own that no human observer could ever hope to track it directly, and yet each one contributing in its own modest way to a picture of the building's condition far more complete than any single person walking its halls could ever assemble alone. At the center of all this quiet observation sits the building automation system, though it would be a mistake to imagine it as any single piece of equipment. It is not a machine in the way the fan or the coils are machines. It is closer to a coordinator, a kind of patient, tireless intermediary standing between every sensor scattered throughout the building and every piece of equipment capable of responding to what those sensors report. It does not itself generate heat or cold or moving air. It simply listens, considers, and quietly instructs, leaving the actual physical work to the fans, pumps, valves, and dampers that answer to it. In this sense, it resembles less a single piece of machinery and more a kind of quiet nervous system threaded throughout the entire structure, connecting the sensors that observe with the equipment that responds, translating one into the other continuously, thousands of times each minute, without ever pausing to rest. No single wire or panel could ever claim to be the whole of it. It exists instead as a distributed presence spread across every mechanical room, every ceiling void, every occupied space the building contains, present everywhere and yet in the way that matters most to the people living and working within its reach, entirely invisible. Its presence within the building is easy to overlook, tucked away in the same unglamorous spaces that house so much of this story so far. In nearly every mechanical room, alongside the fans and coils already encountered, a modest metal cabinet stands mounted to the wall, considerably smaller than the fan's own control cabinet. its interior neatly organized with rows of terminal blocks and carefully labeled wiring, each connection leading out toward a particular sensor or piece of equipment somewhere else in the building. Thin network cables run from this cabinet in orderly bundles, disappearing into the same crowded space above the ceiling shared by ductwork, sprinkler piping, and electrical conduit, carrying their quiet signals onward to identical panels in other mechanical rooms throughout the structure. A handful of small indicator lights blink steadily on the panel's face, confirming, without any need for translation, that communication continues to flow normally along every connected pathway. There is no dramatic display here, no flashing screen demanding attention, only the same quiet, patient hum of electronics doing exactly what they were built to do hour after hour without complaint. A small placard near the cabinet door, much like the one encountered earlier near the fan section, identifies this equipment in the same plain, unembellished language found throughout the mechanical spaces of the building. A system designation and a handful of numbers meaningful only to the technician who might one day need to service it. Nothing about the cabinet's outward appearance suggests the scale of what passes through it. No visible indication that this modest steel box serves as one of perhaps a dozen similar panels scattered throughout the structure, each quietly coordinating its own portion of the building while remaining in constant, invisible contact with all the others. The sensors themselves, feeding this constant stream of observation, are scattered throughout the building in places most people would never think to look. Small, unobtrusive temperature sensors sit mounted on interior walls throughout offices and hallways, often disguised behind simple plastic covers barely larger than a deck of cards, easily mistaken for thermostats and, in a sense, closely related to them. Humidity sensors sit nearby in many of the same locations, quietly measuring the moisture content of the air without ever needing to announce their presence. Deep within the ductwork itself, additional sensors measure temperature and airflow directly, reporting conditions from places no occupant would ever have reason to visit. Pressure transmitters, similar in principle to the ones encountered earlier near the supply fan, continue their quiet monitoring throughout the branch ductwork, confirming that air continues moving exactly as intended through even the farthest reaches of the system. On the rooftop, alongside the air handling unit's own outdoor air intake, a small weather station quietly tracks outdoor temperature, humidity, and sometimes wind, feeding this information back into the building's awareness of the world just beyond its walls. And in more heavily occupied spaces, dedicated carbon dioxide sensors continue their own quiet watch, monitoring the same slow accumulation described so many hours earlier in this story, ready to note the moment a room's occupancy begins to noticeably rise. Each of these small devices, however different in what it measures, shares a certain quiet humility in its design. None of them announce themselves. None of them interrupt the spaces they occupy. A person could work for years in an office without ever noticing the small sensor mounted discreetly near the door, could sit through countless meetings in a conference room without ever registering the presence of the carbon dioxide monitor tucked into a corner of the ceiling. This, too, seems fitting, given the larger philosophy running through the entire system. Just as the fans and coils and ductwork work best when their presence goes entirely unnoticed, so too do the sensors that inform them. gathering their quiet observations from the very edges of rooms filled with people who have no reason to think about them at all. None of these devices, however numerous or however cleverly placed, ever make a decision of their own. A temperature sensor does not decide that a room is too warm. It simply measures the temperature faithfully and without judgment and reports that single number onward through the network to somewhere else entirely. A modest, unglamorous task performed with total reliability over and over, thousands of times each day. Those countless small observations travel quietly through the building's communication network, following the same bundles of thin cables strung alongside the ductwork, arriving eventually at the building automation system where each one is compared continuously and without pause against the condition the building has been instructed to maintain. A room set to remain near a particular comfortable temperature has that target compared moment by moment against whatever the room's own sensor currently reports. When the two figures align closely, nothing further happens. The system content simply to continue its steady watch. When a difference emerges, however small, the system responds not with any sudden dramatic gesture, but with the smallest possible correction capable of closing that gap. Across the length of any single day, this results in an almost uncountable number of tiny adjustments occurring throughout the building, most of them far too subtle for any occupant to ever notice. A damper somewhere opens by a few additional degrees. A valve eases very slightly further closed. The supply fan's speed drifts down by a fraction of a percent, or another fan elsewhere in the building speeds up by a similarly small amount. A pump circulating hot water through the heating coils adjusts its own pace to match a slight change in demand. None of these individual movements accomplishes very much on its own, and yet the accumulated effect of thousands of them occurring continuously throughout the day is precisely what allows a building this large and this complex to remain, from the perspective of anyone standing inside it, remarkably and consistently still. Engineers describe the particular method behind many of these small corrections using a term called PID control, though the underlying idea, stripped of its abbreviation, is closer to simple common sense than to anything especially technical. Picture, for a moment, a careful and endlessly patient caretaker tasked with keeping a room at a particular comfortable condition. Rather than reacting violently to every small change, throwing open a window at the first sign of warmth and slamming it shut moments later at the first sign of a chill, this caretaker instead makes only small measured corrections, watching carefully to see how the room responds before making the next adjustment, gradually easing conditions toward the desired target without ever overshooting it or overcorrecting in the opposite direction. This is, in essence, exactly what the building automation system does at every one of its thousands of individual control points throughout the structure, patiently nudging conditions closer to their target, watching the result, and nudging again, an endless, gentle rhythm of correction that rarely, if ever, calls for anything dramatic. Engineers break this patient behavior down into three quiet components, though understanding the exact names matters far less than appreciating the calm logic they represent together. One component considers how far current conditions sit from the target at this very moment, correcting in proportion to the size of that gap. Another considers how long that gap has persisted, gently strengthening its correction if a small difference has lingered stubbornly rather than resolving on its own. A third considers how quickly conditions are already changing, easing back on its correction if things are already moving swiftly in the right direction, so as not to overcorrect and send them sailing past the target entirely. Woven together, these three quiet considerations allow the system to respond with a kind of practiced patience, neither too hesitant nor too eager, correcting exactly as much as each moment calls for and no more. Most of these adjustments pass entirely without notice. An occupant sitting at a desk absorbed in a spreadsheet or a phone call has no reason to sense the faint, gradual shift as a nearby VAV box eases its damper open by a small amount in response to the morning sun beginning to warm one side of the building. The correction simply happens quietly in the background, resolved long before it could ever grow large enough to become an actual discomfort. This, in its own way, represents the entire philosophy behind the system's design, a preference for countless small invisible corrections over any single large noticeable one, since a building that must make a dramatic adjustment has usually already allowed conditions to drift further than they ever should have in the first place. Our parcel of air, now well along its return journey, remains, even now, a quiet subject of this ongoing observation. Sensors along the return ductwork note its temperature as it passes, some fraction of a degree warmer than the air that first entered the building's occupied spaces, having absorbed a small measure of heat from the room it briefly served. Pressure sensors nearby confirm that it continues moving at the pace the system currently intends. None of these individual readings mean very much taken alone, and yet each one feeds into the same broad, continuous picture the building automation system maintains of the entire structure, a picture updated constantly, informing not only what happens to this particular current of air, but every decision made elsewhere throughout the building in the moments that follow. Beyond these moment-to-moment corrections, the system also maintains a quieter, longer memory of everything it observes. This process, known as trending, involves recording countless readings over time, rather than simply reacting to them in the instant they occur, building a slow, detailed record of how conditions throughout the building have shifted across the hours, the days, and eventually the seasons. A facilities operator, seated at a desk somewhere in the building or perhaps monitoring remotely from an entirely different location, can call up this recorded history on a simple graphical display, watching a smooth line trace the rise and fall of a particular room's temperature over the course of the previous day, or comparing how closely a fan's actual speed has tracked its intended target over the past several hours. These displays themselves tend toward a calm, understated simplicity, a far cry from anything resembling a dramatic control room. A simplified floor plan might appear on screen, small numeric readouts hovering beside each labeled room, updating quietly every few moments as fresh data arrives. Elsewhere, a diagram of the air handling unit itself might appear, its major components rendered as simple shapes and lines, each one displaying its current status in plain, unembellished text. Trend graphs, when called up, unfold as smooth, gentle curves, tracing the quiet rhythm of a building's day, warming gradually as morning arrives, holding steady through the busy hours of midday, easing gradually back down as evening approaches and occupants begin heading home. An operator glancing across a handful of these screens can, in only a few quiet minutes, form a fairly complete picture of the entire building's health, an achievement that would have taken hours of manual walking and checking in the decades before such systems existed. There is a particular kind of quiet satisfaction in this ability, the sense of an entire building's condition made legible at a glance, reduced from thousands of scattered invisible readings into a handful of simple, calm shapes on a screen. An operator noticing a trend line beginning to drift slightly further from its target than usual, well before that drift ever becomes large enough to matter, can often correct the underlying cause quietly, adjusting a setting or scheduling a small piece of maintenance long before any occupant would ever notice a thing. In this way, the recorded history the system maintains becomes less a record of problems already occurring and more a kind of early, gentle warning, allowing the building's caretakers to stay one step ahead of any real disruption. Occasionally, amid this steady, quiet monitoring, the system will raise what engineers call an alarm, though the word itself carries far more drama than the reality it usually describes. An alarm exists not to provoke any sense of panic, but simply to draw a technician's attention toward something worth a closer look, nothing more dramatic in most cases than a small, calm notification appearing on a screen somewhere. A dirty filter alarm might quietly note that the pressure difference across a filter bank, first introduced several chapters ago, has finally crossed the threshold, suggesting a replacement is due. A fan status alarm might note that a particular fan has failed to start when instructed, prompting a technician to investigate before the issue grows into anything larger. A temperature alarm might note that a particular room has drifted slightly outside its intended comfortable range, perhaps due to nothing more than an especially sunny afternoon. A communication fault might simply note that one small sensor, somewhere in the vast network, has temporarily stopped reporting, a technical hiccup solved as often as not by nothing more than a quiet reset. The overwhelming majority of these alarms describe nothing more urgent than routine, unremarkable maintenance, small signals meant only to keep the building's ordinary upkeep running smoothly, long before any occupant would ever have reason to notice a problem at all. An operator reviewing an alarm summary at the start of a shift might find on any ordinary morning only a short handful of entries waiting for attention, each one calmly logged with a timestamp and a plain description, nothing resembling the flashing red urgency such a word might suggest in almost any other context. A filter awaiting replacement, a sensor due for recalibration, a damper actuator reporting a slightly slower response than usual, perhaps worth a look sometime in the coming week. These are the ordinary, unremarkable notes of a building quietly tending to itself, the same kind of small, patient attention a person might give to changing a smoke detector battery or topping off a car's oil. Unremarkable tasks that, precisely because they are handled early and calmly, rarely ever grow into anything more serious. There is a kind of quiet reassurance in recognizing just how much of this constant, careful checking happens entirely without drama. An endless procession of small confirmations and small corrections, each one so modest on its own that none would ever earn a second glance, and yet together forming the invisible foundation beneath every comfortable, unremarkable hour spent inside a well-run building. thousands of these tiny decisions unfold every single minute across a structure of any real size, no single one of them dramatic, no single one of them memorable, and yet their combined patient effect is precisely what allows a building to feel, to anyone standing inside it, entirely calm and entirely stable, as though comfort were simply a natural, effortless property of the space itself, rather than the product of an unceasing, invisible conversation taking place just beyond sight. It is a strange kind of intelligence, if it can even be called that, one with no ambition beyond steadiness, no goal beyond quiet equilibrium. It does not think in any sense a person would recognize, does not wonder or imagine or plan beyond the narrow practical horizon of the next few minutes. And yet, in its own limited mechanical way, it manages something genuinely remarkable, holding an enormous, complicated structure in a state of continuous, gentle balance, hour after hour, entirely without the need for anyone to stand watch over it directly. Our parcel of air having passed at last back toward the return ductwork, leading once more to the air handling unit, has been guided throughout this entire journey not only by the physical architecture of fans and ducts already described, but equally by this quieter, less visible layer of coordination, a steady exchange of information running parallel to every foot of its physical path, informing each small adjustment along the way, from the angle of a damper blade to the speed of a distant pump, all of it working together in a kind of patient, continuous harmony that never truly rests. Outside, the sky beyond the building's windows has not yet begun to lighten, still holding its own deep, quiet shade of blue, though somewhere beyond the horizon, morning continues its own slow approach. Tomorrow may arrive warmer than today, or noticeably cooler. It may carry with it a heavier, more humid air, or a drier one entirely. The building, in its own patient way, holds no particular expectation for what the coming hours might bring. Whatever conditions the next sunrise happens to deliver, the same quiet sensors will note them, the same careful system will weigh them, and the same unhurried, invisible conversation will continue exactly as it always has, ready, as it has been every night before this one, to meet whatever the changing seasons ask of it next. Chapter 7. Through the Seasons. Dawn arrives slowly on an early spring morning, the sky above the building easing from deep blue into a soft pale gray, the first faint hint of gold gathering along the eastern horizon. Somewhere on the rooftop, our familiar parcel of air drifts once again toward the outdoor air intake, drawn in through the same aluminum louvers, past the same fine mesh screen, beginning a journey that by now feels almost like an old, well-worn path. The building has awakened to another day, its fans stirring gently to life as they have every morning before this one, its dampers easing open, its whole quiet machinery settling into the familiar rhythm this story has followed from the very beginning. And yet, though the equipment itself has not changed in any meaningful way, the world just beyond its walls never stops changing around it. The same louvers that once admitted the cold, still air of a winter night now welcome something entirely different. A morning carrying with it the particular character of spring, cool and slightly damp, tinged faintly with the mineral scent of recently thawed soil and the sweeter, more delicate scent of new growth beginning somewhere nearby. Afternoons will arrive mild and unhurried in the weeks ahead, warm enough to coax open the first blossoms along the building's landscaped entrance, cool enough still that a jacket left at home might be missed by midday. A fine dusting of pollen drifts invisibly through this same morning air, tiny grains carried for miles on the breeze, destined in only a few moments to meet the same bird screen and filter banks that have quietly managed every other kind of airborne visitor throughout this story. Occasional rain showers will pass through in the days ahead as well, gentle and unpredictable, drumming softly against the rooftop enclosure before clearing again to reveal a washed, freshly scented sky. There is a particular quality to spring air that no other season quite manages to replicate, a certain restlessness to it, cool one moment and unexpectedly mild the next, as though the atmosphere itself has not yet settled on which direction the years should take. The building, for its part, shows no impatience with this uncertainty. It simply measures what arrives at any given moment and responds accordingly, content to let the season reveal itself gradually, rather than anticipating any particular outcome in advance. The building, in its own quiet way, notices all of this. Somewhere within the building automation system, a small but meaningful calculation begins to shift as spring settles in. On a morning this mild, with outdoor temperatures resting comfortably close to what the building actually wants to maintain indoors, the system recognizes an opportunity too useful to pass by. Rather than relying so heavily on the mechanical cooling system to bring indoor air to a comfortable temperature, it can instead simply draw in more of this pleasant outdoor air directly, allowing the mild morning itself to do a portion of the work the chiller would otherwise have to perform alone. Engineers call this strategy economizing, and it unfolds here exactly as gently as everything else in this story has unfolded so far. The outside air damper, so carefully modulated on that first quiet night this journey began, now eases open somewhat farther than it typically would, admitting a larger share of the naturally cool morning air, while the mixing dampers adjust in turn, welcoming less of the warmer return air than they might on a more demanding summer afternoon. No alarm sounds to mark this shift. No light blinks any differently than it did the day before. The building simply takes advantage of favorable weather, the way anyone might choose to open a window on a particularly pleasant morning rather than reach immediately for a thermostat. The weeks pass and spring gradually loosens its grip on the mornings, the days growing steadily longer, the sun climbing a little higher with each passing week until, almost without anyone quite noticing the precise moment of transition, summer has fully arrived. Now the rooftop tells an entirely different story. By early afternoon, the flat black surface surrounding the air handling unit's enclosure has absorbed hours of direct sun, radiating a heat of its own that shimmers faintly visible above the tar and gravel. The pavement of the parking lot below holds its own version of this same accumulated warmth, hot enough that a hand pressed briefly against a parked car's hood would draw back quickly. Nearby buildings, their glass facades catching and reflecting the afternoon light, contribute their own small measure of radiant heat to the surrounding air, an entire landscape of concrete and asphalt and glass quietly amplifying the sun's effect long after any single ray has actually struck the ground. Even the mechanical room itself carries a different feeling on an afternoon like this. the ambient warmth of the building pressing in a little more insistently than it did during the cooler months. The fans and motors working within air that offers less natural cooling of its own than it once did. A technician passing through during one of these summer afternoons might notice the faint sheen of perspiration gathering more quickly than it would on a mild spring morning, a small human echo of the same thermal burden the machinery around them has been quietly managing all day. The air drawn in through the louvers on an afternoon like this arrives noticeably warmer and considerably more humid than anything encountered during the cooler months of this story, carrying with it the thick, heavy quality so familiar to anyone who has stepped outside during the peak of summer. Inside the mechanical room, the cooling coil now works considerably harder to manage this shift, the chilled water arriving from the building's chiller plant working overtime to draw away the substantial heat this warmer air carries with it, or in buildings relying instead on direct expansion coils, the refrigerant itself cycling more vigorously to keep pace with the rising demand. Condensation gathers far more visibly here than it ever did during the milder months, droplets forming quickly and steadily across the aluminum fins, falling in a far more constant rhythm into the drain pan below, the condensate piping carrying away a noticeably greater volume of water than it managed on any spring morning. This intensified condensation points toward something worth pausing on, a concept engineers describe as latent heat, though the underlying idea remains as simple and intuitive as anything encountered so far in this journey. Not all of the energy locked within a parcel of humid air announces itself as measurable temperature. A significant portion of it instead hides within the water vapor itself, bound up invisibly in the very structure of that moisture, energy that only reveals itself and only releases itself at the moment that vapor condenses back into liquid water. This is why removing humidity from the air, as the cooling coil does so thoroughly during these warm summer afternoons, accomplishes something beyond simple comfort. It draws away not only the sensible heat a thermometer could easily measure, but also this hidden latent heat carried invisibly within the moisture itself, a double duty the coil performs quietly and continuously, hour after hour, throughout the hottest stretch of the year. Our parcel of air, passing through this same coil on a July afternoon, emerges considerably drier and considerably cooler than it would have on the spring morning encountered only a short while ago in this story, the fan working somewhat harder now to push this denser, more thoroughly conditioned air onward through the same familiar network of ducts, out through the same diffusers, into offices and hallways, now working overtime themselves to hold back the full weight of the summer heat pressing steadily against the building's windows and walls. As August fades and September settles in, the character of the mornings begins slowly and almost imperceptibly to shift once again. The air arriving through the louvers now carries a distinct crispness absent from anything encountered during the long summer stretch, a coolness that lingers a little longer into the morning before the sun finally burns it away. Somewhere beyond the parking lot, the first scattered leaves have begun drifting down from the trees lining the property, catching briefly against the base of the louvered intake before a passing breeze carries them onward, occasional stragglers finding their way harmlessly against the fine mesh screen that has stood guard there since the very beginning of this story. Evenings, too, arrive earlier now, the sun dipping below the horizon a little sooner with each passing week. The building's exterior lighting clicking on that much earlier than it did only a month before. Inside the mechanical room, this gradual seasonal shift registers just as gradually. The cooling coil, having worked so steadily through the summer months, begins calling for its services a little less often as the outdoor air grows naturally milder, while the heating coil, largely dormant through the warmest stretch of the year, begins to stir once again, called upon with increasing frequency as the earliest, coolest mornings of autumn arrive. There is no single dramatic moment marking this transition, no particular day when summer visibly ends and autumn visibly begins. The building instead drifts smoothly from one season into the next, its equipment quietly favoring first one coil and then gradually the other, following the same patient logic that has governed every small adjustment throughout this entire story. A slow, continuous recalibration rather than any sudden change of course. And then, just as gradually, autumn too gives way to winter. The mornings arriving now in a darkness the building's occupants have not experienced in months. The rooftop itself sometimes catching a thin, delicate coating of frost before the earliest arrivals ever step through the front doors. Where a cooling tower stands nearby tasked with the important work of rejecting excess heat from the building's chiller plant, a faint column of steam sometimes rises visibly from its structure on the coldest mornings, catching the first weak light of sunrise before dispersing quietly into the surrounding air. A small, visible reminder that even in the depths of winter, some corner of this building's machinery continues quietly working with warmth of its own. Inside, along the piping that carries hot water toward the heating coils described so many chapters ago, that same warmth circulates now with a renewed sense of purpose. The boiler working through the coldest stretches of the season with a steadiness matched only by the chiller's own efforts during the peak of summer. The two systems, cooling and heating, rarely operate with equal intensity at the same time, the building's overall demand shifting like a slow pendulum between them across the span of a full year, each one taking its turn as the season calls for it, neither ever entirely idle for very long. The outdoor air arriving through the louvers on a morning like this carries an entirely different character than anything encountered earlier in this story. A sharp, clean coldness that would, left unmanaged, threaten real harm to the delicate coils waiting just inside. Here, the building's careful winter preparations reveal themselves in full. In many systems, a preheat coil stands positioned early in the airstream, well before the main coils encountered so many chapters ago, tasked with taking the very coldest edge off incoming outdoor air before it ever reaches the more sensitive equipment further along the path, warming it only enough to remove any risk of frost or freeze while leaving the more precise, comfortable tempering to the coils downstream. Elsewhere, the building automation system quietly enforces outdoor air limits during the coldest hours, restricting just how much frigid outside air the dampers are permitted to admit at any one time, favoring instead a slightly larger share of already warmed return air until conditions outside grow a little more forgiving. And the freeze-stat sensors introduced earlier in this story continue their own quiet vigilance throughout every one of these cold mornings, stretched patiently across the ductwork, ready even now, as they have been every winter before this one, to intervene instantly should any pocket of dangerously cold air ever slip past every other safeguard standing in its way. None of this protective effort ever announces itself with any real drama. The building simply adjusts, moment by moment, the same quiet correction encountered so many times throughout this story, scaled now to meet the particular demands of the coldest season, protecting its own delicate machinery with the same patient, unhurried care it has shown toward every other challenge encountered so far. Each morning, regardless of season, carries with it a particular quiet ritual worth pausing on, one easy to overlook amid the larger sweep of the changing year. Long before the first car pulls into the parking lot, long before the first key turns in the front door, the building has already begun preparing itself for the day ahead. Guided by a schedule set months or even years earlier, and refined continuously since, the building automation system begins gradually increasing fan speeds and adjusting damper positions well ahead of the building's typical opening hour, allowing rooms that spent the night resting at a slightly relaxed condition to ease gently back toward full comfort before anyone ever arrives to notice the difference. On a cold winter morning, this might mean the heating system beginning its work a full hour or more before the earliest employee unlocks the door. On a mild spring morning, the same warm-up period might require far less effort, the building needing only the gentlest nudge to return to its daytime comfort. Either way, the result unfolds the same way it always has throughout this story, quietly, invisibly, so that by the time the first person steps into the lobby, the building already feels exactly as it should, offering no hint of the darkness and stillness that occupied the very same space only an hour or two earlier. This same rhythm plays out in reverse each evening, as the last occupants gather their belongings and head for the parking lot, the building settling gradually into what engineers call night setback. Rather than continuing to maintain the same precise comfort demanded during occupied hours, the system now permits conditions to drift a little further from their usual target, temperatures easing slightly warmer in summer or slightly cooler in winter, always remaining safely within a range that protects the building and its contents while conserving a meaningful measure of energy across the many empty hours that follow. This gentle drift never announces itself as neglect. It represents instead a kind of practical wisdom, an acknowledgement that a room with no one inside it has no real need to be held to the exact same standard as a room filled with people, freeing the building's equipment to rest just a little more easily until the next cycle of warm-up begins again. Not every day, of course, unfolds according to this same gentle, predictable rhythm. Some mornings arrive carrying weather far outside the ordinary run of the seasons, and here too the building's response remains remarkably consistent in spirit, if not always in scale. A sudden summer heat wave, pushing outdoor temperatures well beyond anything the cooling season typically demands, calls for the chiller plant and supply fans to work harder and longer than usual, the system responding with the same measured incremental adjustments encountered throughout every calmer day. Simply ask now to make more of them, more often, until the unusual heat finally breaks. A period of unusually heavy rain might call for closer attention to humidity control, the cooling coils working to manage moisture levels even on days when temperature alone would not otherwise demand their full effort. On occasion, smoke drifting in from a distant wildfire might settle over the region, And here, the building's filtration system, quietly introduced so many chapters ago, takes on an added significance, its filters working to strain a far heavier burden of fine particulate from the incoming air than on any ordinary day. The differential pressure sensors watching this accumulation just a little more closely than usual. An unexpectedly hard freeze arriving earlier in the season than anyone anticipated calls upon the same protective systems described only a short while ago. The preheat coils and outdoor air limits and freeze stats standing ready regardless of the calendar's expectations. In every one of these unusual circumstances, the building's fundamental response remains the same as it has been throughout this entire story, not through any single dramatic gesture, but through the accumulation of thousands of small, careful adjustments scaled up as needed, patiently working toward the same steady goal it pursues on every ordinary day. Our parcel of air, whichever morning happens to carry it through this story, arrives each time by a slightly different path. Some days it enters carrying the mild dampness of spring, other days the thick humidity of summer, the crisp clarity of autumn, or the sharp cold of winter. The precise mixture of outdoor and return air shifts subtly from one season to the next. The exact degree of heating or cooling applied along the way changes with the weather outside, and yet the destination toward which every single parcel is quietly guided remains, in every case, exactly the same. Comfort, health, a steady supply of clean, properly tempered air, delivered without fail into whatever room happens to be waiting for it, regardless of what the sky outside has chosen to do on any particular day. Seasons continue to turn in this fashion, one following gently into the next, spring easing into summer, summer into autumn, autumn into the quiet stillness of winter, and then, in time, back around to spring once again, a cycle repeating itself year after year with a patience the building itself seems, in its own quiet, mechanical way, to share. The building ages through all of this, its exterior slowly weathering, its interior finishes gradually updated and replaced as fashions and needs shift over the years. The people who occupy its offices come and go as well, careers beginning and ending, companies moving in and eventually moving out, entirely new tenants arriving to fill spaces once occupied by others who have long since left this particular address behind. Through all of it, the same fundamental machinery quietly continues its work, largely unchanged in its essential design, even as everything around it shifts and turns over, faithfully serving whoever happens to occupy the building on any given day, indifferent to the particular names on the lease, attentive only to the steady, ordinary needs of whoever walks through the doors each morning. Somewhere along the way, a fan belt will be replaced, a filter bank upgraded to a newer standard, a control panel swapped for a more modern version capable of the same essential task with a slightly different interface. These changes arrive gradually, one small component at a time, so that no single year ever marks a dramatic break from the one before it. The building simply continues, patched and maintained and occasionally modernized, its underlying rhythm remaining recognizably the same decade after decade, the way a river remains recognizably itself even as every drop of water within it is, at any given moment, entirely new. As this particular day, like every day before it, eventually draws toward its close, the building begins, once again, its own familiar unwinding. lights across the upper floors click off in scattered, uneven succession as the last few occupants gather their things and head for the elevators. Footsteps that filled the hallways only an hour earlier grow fewer, then rarer still, until at last the corridors fall silent in that particular way only a large building can fall silent, a stillness carrying its own peculiar weight. The parking lot below empties gradually, one set of headlights after another pulling away into the gathering dusk, until only a handful of vehicles remain, and then eventually none at all. And yet, high above those darkened, empty hallways, in the same mechanical rooms and rooftop enclosures that have carried this entire story from its very first moment, the hidden machinery does not pause. The fan continues its steady, patient turning. The coils continue their quiet exchange of warmth and coolness. The dampers continue their slow, deliberate adjustments. And somewhere within the small steel cabinet of the building automation system, the same invisible conversation continues without interruption, unconcerned with whether anyone remains inside the building to notice it. Most people, glancing up at the darkened windows of an office tower late in the evening, would assume, without a second thought, that the building itself has simply gone to sleep for the night. But here, deep within its hidden spaces, far from any window a passerby might glance toward, another quiet night of unseen work has only just begun. Chapter 8. The building never really sleeps. Evening settles over the building once again, the way it has settled over it every evening before this one, the sky beyond the windows shifting slowly through its familiar sequence of colors, a warm gold fading into a deepening blue, and finally into the soft, uniform dark that will hold the city until morning. On the upper floors, office lights begin switching off one by one, an uneven, unhurried procession of small darknesses spreading gradually across the building's face. The last meeting of the day finishes in a conference room somewhere near the center of the structure. Chairs pushed back, papers gathered, a light switched off on the way out the door. Footsteps in the hallways grow fewer, then rarer still, until eventually none remain at all. The elevators, having spent the day rising and falling in their steady rhythm, grow quieter too, settling for long stretches at whatever floor last called them, their doors closed, their cars resting in stillness. Outside, the parking lot empties slowly, one set of headlights sweeping across the pavement and then away, then another, then a long pause, and then nothing more. A security guard makes a slow, unhurried circuit of the ground floor lobby, checking doors already checked an hour earlier, more out of habit than necessity, before settling back into a chair near the front desk. A single desk lamp casting the only light in an otherwise darkened room. Somewhere above, a lone cleaning crew moves quietly from floor to floor, emptying wastebaskets and running a vacuum across the carpet in slow, methodical passes, the only human activity remaining anywhere in the building's upper levels. Within the hour, even this will fade. The cleaning cart wheeled back into its closet, the lights along that particular floor clicking off one final time until morning. To anyone watching from the street, the building would appear by now to have gone entirely to sleep, its darkened windows offering no hint of anything stirring within. But this is only what can be seen from the outside, only the surface of a much larger and much quieter truth. Behind the walls, above the ceilings, deep inside the mechanical rooms, this story has visited so many times already. The building continues its work without interruption, exactly as it has continued through every night described so far, exactly as it will continue tonight. Our familiar parcel of air, having completed so many countless journeys throughout the course of this single day alone, each one nearly identical to the one before it, and yet each one, in its own small way, entirely its own, begins yet another. There is nothing to distinguish this particular passage from the thousands that preceded it earlier today, and yet it unfolds all the same patient sequence of events, carrying it forward once more into the quiet dark. Inside the mechanical room, the air handling unit continues its steady, unhurried rhythm, though the character of that rhythm has shifted now that the building's occupants have gone home for the night. The fan, which spent the busier hours of the afternoon turning at a noticeably brisker pace to meet the demands of a fully occupied building, now eases back to something more modest, its blades still turning continuously, still moving a considerable volume of air with every rotation, simply asked now to do somewhat less of it than during the day's peak. Nearby, the variable frequency drive continues its own quiet work, its small display glowing steadily in the dim light, making the same tiny, continuous adjustments it has made throughout every hour described in this story, nudging the fan's speed fractionally lower here, fractionally higher there, tracking the building's reduced but still very real overnight needs with the same careful attention it gave to the building's busiest afternoon hour. Elsewhere along the same mechanical pathway, dampers reposition themselves in small, deliberate increments, easing toward whatever configuration best matches the current, gentler demands of an unoccupied structure. Heating and cooling valves make their own small corrections in turn, opening or closing by the narrowest of margins in response to the same patient calculations that have governed every adjustment throughout this entire journey. Somewhere beneath the floor, in pipe runs largely forgotten by anyone who does not maintain them directly, pumps continue circulating water through miles of hidden piping, carrying warmth toward heating coils and away from cooling coils in the same unbroken circulation described so many chapters ago, indifferent to the hour, indifferent to the emptiness of the halls above. The sound within the mechanical room carries its own particular texture at this hour, quieter now than during the day, though never entirely silent. A soft, continuous whisper of moving air fills the space evenly, joined by the low, steady hum of electric motors turning somewhere within their casings. Beneath these more immediate sounds, if a person stood still long enough to notice, the faint, distant movement of water might be sensed as much as heard, a subtle vibration traveling through the pipes and the concrete floor beneath them. Every so often, a small mechanical click punctuates the steady background hum, an actuator completing some minor adjustment, a relay closing somewhere within a control panel. Small sounds that arrive and fade so quickly they would be easy to miss entirely. Scattered across the equipment throughout the room, indicator lights continue their patient glow in the near darkness, small points of green and amber standing out clearly now that the room's overhead lighting has, in many buildings, dimmed or switched off entirely for the night, conserving the same modest energy the rest of the building's systems are working so carefully to conserve. There is a particular stillness to a mechanical room at this hour, one distinct from silence itself. Nothing here is truly quiet, not in the way an empty office upstairs has grown quiet, and yet nothing here is loud either. The room exists instead in a kind of steady, ongoing murmur, a sound so constant and so evenly distributed that it eventually stops registering as sound at all, settling instead into something closer to a felt presence, the way the beating of one's own heart eventually fades from conscious awareness despite never actually stopping. Occasionally, this quiet solitude is interrupted gently by the arrival of a maintenance technician making evening rounds, moving through the mechanical spaces with the unhurried familiarity of someone who has walked this same route many times before. A flashlight beam sweeps briefly across the casing of the air handling unit, pausing here and there as an access door is opened, a fan belt inspected for the faintest sign of wear, a bearing listened to closely for anything beyond its usual smooth, steady turning. A filter, perhaps nearing the end of its useful service, gets pulled and replaced with practiced, unremarkable efficiency, the old one set aside, the new one slotted neatly into place within its frame. Nearby, the technician might pause at a small screen mounted to the wall, reviewing the same graphical displays introduced earlier in this story, floor plans and trend lines glowing softly in the dim room, confirming at a glance that everything continues to operate within its expected range. Most of this quiet evening attention has little to do with anything resembling failure or crisis. The goal, almost without exception, is prevention rather than repair. The patient, unglamorous work of noticing a small irregularity today so that it never has the chance to become a larger one tomorrow. A belt tightened slightly before it can slip. A bearing lubricated before it can begin to wear unevenly. A filter replaced before its accumulated dust ever meaningfully restricts the flow of air passing through it. None of this work announces itself with any urgency. It simply happens, quietly and routinely, the same unremarkable diligence that has kept this particular building running smoothly for years, performed by people whose names most occupants will never learn, whose work most occupants will never think to appreciate, precisely because that work succeeds most completely when no one ever notices it was needed at all. Somewhere else in the building, perhaps in a small office set aside for exactly this purpose, or perhaps monitored remotely from an entirely different building altogether, a control room holds its own quiet vigil through the night. Computer monitors glow steadily in an otherwise darkened room, displaying the same simplified floor plans and trend graphs described earlier in this story. Temperature readings updating in small, unhurried increments, airflow figures holding steady within their expected ranges, static pressure readings tracing their familiar gentle patterns across the screen. No one sits anxiously monitoring these displays every moment of the night, watching for some dramatic event that will, on the overwhelming majority of nights, simply never come. The screens exist instead as a kind of quiet reassurance, available to be checked whenever necessary, confirming, whenever a glance falls upon them, that the building continues to watch over itself exactly as it should. Our parcel of air, indistinguishable now from the countless others that have passed through this same sequence throughout the day, continues its familiar cycle. Outside air drawn in through the rooftop louvers, the quiet meeting with return air inside the mixing box, the gentle sifting of the filter banks, the patient exchange of warmth or coolness at the coils, the steady pressure of the great turning fan, the long passage through branching ductwork, out through a diffuser, into a room now empty and dark, and back again through a return grill toward the mechanical room where the entire sequence began. There is no need, at this point in the story, to walk through every individual step once more. The listener by now recognizes this particular journey the way one recognizes the shape of a familiar street, each turn expected, each landmark exactly where it should be. If the perspective of this story were to widen now, drawing back slowly the way a documentary camera might rise gradually above a single rooftop, an entirely similar scene would reveal itself at the building next door. There, too, an air handling unit continues its own quiet nighttime rhythm, its own fan turning steadily, its own coils exchanging warmth and coolness, its own building automation system conducting its own invisible conversation with sensors scattered throughout its own halls. Draw back further still, and the same pattern repeats itself across an entire city skyline, one darkened tower after another, each one appearing from the street to have gone completely still for the night, and each one, in truth, continuing its own hidden work exactly as thoroughly as the building this story has followed so closely from its very first chapter. Picture for a moment the view from somewhere high above, the kind of vantage point only a low-flying plane or a tall neighboring rooftop might offer. The city spread out below in a scattered field of dark windows, interrupted here and there by the lonely glow of a security light or an all-night convenience store. From this height, nothing would suggest that anything at all is happening within any of these silent, sleeping structures. And yet beneath nearly every one of those darkened roofs, the same essential story continues to unfold, a hidden network of fans and coils and quiet electronic conversation, entirely invisible from above, entirely indifferent to whether anyone happens to be watching. Across this single city alone, thousands of buildings maintain this same quiet vigilance through the night, each one operating its own version of the machinery described throughout this story, each one running its own fans, its own pumps, its own patient sequence of sensors and dampers and valves. Multiply this across every other city sharing the same night sky, across every other country currently experiencing this same late, quiet hour, and the true scale of what has been described in this documentary becomes almost impossible to hold in mind all at once. Millions of air handling units in this exact moment continue turning their millions of fans, moving their own patient rivers of air through their own webs of ductwork, serving buildings whose occupants, almost without exception, have no reason to think about any of it at all. Somewhere among them, an enormous, unknowable number of people are sleeping peacefully at this very moment, resting comfortably in rooms whose temperature and freshness depend entirely on machinery they will never see, will never think about, and, in the truest sense, will never need to. There is something worth pausing on in the sheer reliability of all this hidden machinery, a quality easy to take entirely for granted precisely because it so rarely calls attention to itself. Many of these systems operate every single hour of every single day for decades at a stretch, running continuously through changes of ownership, changes of tenant, changes in the very technology surrounding them. Furniture is replaced, computers are upgraded. Entire industries rise and fall within the same office walls that once housed something else entirely. And through all of it, the same essential machinery, patched here and there, occasionally modernized but fundamentally unchanged in its purpose, continues its steady work, indifferent to whatever business happens to occupy the floor above it this particular year. attentive only to the same simple, enduring task of keeping the air clean, comfortable, and quietly moving. There is a kind of quiet dignity in machinery built to outlast so much of what it serves. Equipment that will watch entire careers begin and end within the same walls it conditions, that will outlive the particular arrangement of desks and cubicles occupying any given floor at any given moment, that will, in many cases, still be turning its same patient fan long after every person currently walking this building's halls has moved on to somewhere else entirely. It asks for nothing in return for this long service beyond the occasional filter change, the occasional inspection, the occasional small correction offered by a technician passing through on a quiet evening round. Outside, the weather continues its own indifferent progression through the night, entirely unconcerned with anything happening within the walls it surrounds. On some nights, rain falls steadily against the rooftop, drumming softly against the metal enclosure housing the air-handling unit, the sound carrying faintly down through the ductwork before fading into the general hum of the mechanical room below. On others, snow gathers instead, settling in a quiet, undisturbed layer across the rooftop's surface, insulating the equipment beneath it in its own accidental temporary blanket. Some nights carry nothing more dramatic than a still, warm summer darkness, the air outside barely moving at all, content simply to sit in place until the first stirrings of morning finally arrive to disturb it. On certain nights, a slow fog rolls in from somewhere beyond the city's edge, drifting silently between the buildings, blurring their outlines into soft, indistinct shapes, muffling whatever sound might otherwise carry across the empty streets. Whatever the weather chooses to do on any particular night, the building responds in exactly the manner described so many times throughout this story, adjusting its dampers, its valves, its fan speeds in small, unhurried increments, quietly accommodating whatever the sky above has decided to bring. As the night deepens further, moving past midnight and into the deepest, stillest hours of early morning, the mechanical room settles into its most minimal, most conservative rhythm. The fan continues turning, though now at its most modest pace of the entire day, moving only the small measure of air the building's near-total emptiness actually requires. The pumps continue their circulation, the valves hold their positions with only the occasional small correction, the entire system settling into something close to equilibrium, a steady, unchanging state disturbed only by the smallest, most necessary adjustments. Nothing dramatic occurs during these hours. Nothing dramatic needs to occur. The building simply continues, patient and unhurried, exactly as it has through every other night this story has described. Our parcel of air, somewhere within this deep, quiet stretch of the night, continues its own endless passage, indistinguishable at this point from the very first parcel introduced so many chapters ago, and equally indistinguishable from whatever parcel will follow immediately behind it. It has no true beginning, this particular journey, since some version of it has been unfolding for as long as this building has stood, and it has no true ending either, since some version of it will continue long after this particular night gives way to morning. It exists simply as a continuous, unbroken cycle, outside air drawn in, filtered, tempered, delivered, returned, and drawn in again, a loop repeating itself with such patient consistency that the distinction between one full cycle and the next begins to feel almost beside the point. And then, gradually, so gradually that no single moment could ever be pointed to as the precise instant of change, the sky beyond the building's windows begins, once again, to lighten. A faint gray softens the deep black of the horizon first, barely perceptible, followed slowly by the first hesitant suggestion of gold along the very edge of the sky. Somewhere on the rooftop, the small outdoor weather sensor introduced earlier in this story quietly registers the earliest shift in outdoor temperature, the coolest point of the entire night finally beginning its slow reversal as the sun, still well below the horizon, begins nonetheless to make its presence gradually felt. The building automation system notices this shift in the same quiet, unremarkable way it notices everything else described throughout this story. Comparing the new reading against its own patient schedule, recognizing that the hour has arrived once again to begin preparing for another occupied day. Somewhere within the mechanical room, the fan begins, slowly and deliberately, to increase its speed, the variable frequency drive easing the frequency of its electrical supply gradually upward, coaxing the great wheel toward a livelier pace than it has held throughout the deep stillness of the night. The outdoor air dampers shift as well, opening incrementally wider in preparation for the fresh air the day ahead will soon require. Throughout the building, hundreds of VAV boxes, dormant through the quietest hours of the night, begin their own small stirrings, preparing the countless individual rooms they each serve for the arrival of people who remain, for now, still fast asleep in homes scattered across the surrounding city. The building in this way begins waking long before any of its actual occupants do, easing itself gently back toward full readiness across a slow, unhurried span of time, so that by the moment the first key eventually turns in the front door, the entire structure will already feel exactly as it should, offering no outward sign of the long, quiet night that came before it. This is, in its own way, the same quiet wonder that opened this very documentary so many chapters ago, returning now, full circle, to close it. Today, as on every day before it, most people will walk into this building without a single thought for the hidden engineering surrounding them on every side. They will simply notice without noticing that the air feels comfortable, that the temperature feels right, that the whole space simply works, exactly as they have always assumed it would, exactly as it has worked every day they have ever spent within these walls. They will have no reason to think about the louvers admitting the first parcel of morning air, no reason to consider the filters quietly straining away whatever the outside world happened to carry in, no reason to picture the coils exchanging their patient warmth and coolness, the great fan building its steady pressure, the dampers and valves making their thousands of small corrections, the invisible conversation of sensors and controllers holding the entire structure in its careful, continuous balance. But above the ceiling tiles they will walk beneath today. Behind the walls they will lean against without a second thought. Inside the quiet mechanical rooms most of them will never once visit in all the years they spend working here. The building will continue exactly as it always has, breathing in its own slow mechanical rhythm, drawing in the world outside and offering back, in return, something calm and clean and comfortable, asking nothing in return but to be left, quietly, to its work. It has done this every day since it was first built, through every season this story has followed, through every ordinary night and every unusual one, through every occupant who has ever walked its halls and everyone who has yet to arrive. And it will do so again tomorrow and the day after that, for as long as anyone continues to need the quiet, steady comfort it has offered all along, without ever once asking to be noticed. The last of the night stars fade slowly from view as the horizon continues its patient brightening, the deep blue of early morning giving way by degrees to something softer and paler, the same slow transformation that opened this very story so many chapters ago now arriving once more, as it always does, as it always will. Somewhere far below, a single early car turns into the still empty parking lot, its headlights sweeping briefly across the pavement before switching off, the first small sign of a new day beginning to gather. Somewhere above the rooftop, as the last stars fade into the pale wash of early morning light, the great fan continues its patient turning. The coils continue their quiet exchange, and the building, exactly as it did at the very beginning of this story, simply goes on breathing, slow and steady, beneath a sky that is only now, gently, beginning to grow bright.